Starting the stream. We're on at 2,670 kilobits per second. And we have a transcoder, which is always nice to see. It's Friday the 13th, and this is the 13th stream in this series. Hello! I'm working on the grammar for domain-specific language for parsing binary data. I think the last thing that I worked on this morning was key value and fitting it into an expression. I think I put it down here, and I just fixed a bug where I'd forgotten the delimiters, and it caused the grammar to get so ambiguous that it looked like it was in an infinite loop building, but now it's working, which is always good to see. 70 test passing. So we're going to continue on with more grammar rules. Let's move this a bit up, shall we? Can I just like drag it around? Can I drag this like up to the top? And maybe close some of these things we don't need to see anymore. Keep that. Do I need this one? I don't really need that one. I don't really need that one either. Might need expression 0. Don't need key values or expression lists. Expression? Possibly. Let's put format I up here along with token. Okay. And maybe the format first. And then that. Yeah. Okay. What are these bookmarks that I have? Bookmark there and bookmark there. I should remember that I have those bookmarks. Maybe put another bookmark in the data too. That way, when people ask me for explanation of what I'm doing, open with by hex editor and then can I put a bookmark there? Can't put a bookmark there. How sad. Okay, well, I tried. Put a bookmark on grammar. So I have the original grammar for GIF, and then there's my version of it, and then here's where the grammar is. Let's put another one in the Y file. Let's anchor it at the top here. There we go. Okay. Now we can kind of jump around with the bookmark thing. In fact, I'm gonna use it right now. Okay, so key values is in there. Oh, the other thing was that we have expression list now. And I have optional expression list, right? A D list. Yeah, we have optional expression list. Cool. Okay, then there were some grammar rules that I couldn't get to before, but now I can because I have expression list. Like a function call, because that's an identifier with parentheses and then an expression list, which is the arguments of the function. So what if I do that next? I'll do a function call. All right. Test first, I guess. I suppose we're putting that in expression 0 because why not, right? Above the error patterns. Here we go. Function call. Function call. Okay. Function call starts with an identifier. So let's call it foo to string needed to put a bookmark there so I don't have to search for it again. Here we go. Hey there, Rally Monkey. Wow, it's been a while. You are the first in stream numbered Lucky 13 on the 13th of October, which happens to be a Friday, to chat in the stream. So hello. You win the Friday the 13th Stream 13 First Post Award, which is a customized hello. Here, we'll give you all the hellos that I have. I have this hello, and then I have this hello, and then I have this hello. There we go. You get all the hellos. Always rushing out in the morning with kids to school. I typically start streaming. Well, I have the VODs, you know. Sarian's been like mostly watching on the VODs. But see, I also try now to stream like in the evenings when I have, you know, some extra time, like on the weekend. Okay. So I don't know if you've seen any of the preceding streams, Rally Monkey, but this series is about resurrecting an old tool that I have called the DataDisintegrator, that you can describe a file format in a custom language I came up with, and then you can take that with the tool and have it apply that format in an in-order traversal to some data that matches that format, and it will pick apart the pieces. So first 3 bytes GIF, next 3 bytes version number, next 2 bytes after that is the width of the GIF. To us humans, it looks like that. To the computer, it looks like that. So to make heads or tails of this, we describe the format and then run it through the tool, and we can get all these little interesting things about it. Like the fact that there are 61 images in that, and it's 300 by 300 and all sorts of other cool things. So 3 pieces of this tool. First is the lexer, which, yeah, if I can build it, turns the program into a stream of tokens. Remember this from a long time ago? I think I shared a little bit with you. Yeah, probably before the streaming, right? So yeah, that's an identifier. That's a symbol. Identifier, symbol, keyword, identifier, symbol, another keyword. So that's all of this that I just went over. Yeah, prior to the streaming. So that's what a lexer does. Lexical analysis. It analyzes these characters to turn them into tokens. So the tokens go feed into the next step, which is the grammar of the language. So, for example, the grammar of my language is that a program or a file that we're compiling is a sequence of format specifications. So here's how we do a sequence in Bison format. You have an empty rule so that you can start with nothing, and then with that nothing, you can add another format to it. Notice that that's plural, that's singular. This is a recursive rule. So you can have 0 formats followed by 1 format, or you can have 1 followed by 1, or you can have 2 followed by 1, and it can repeat. So that's kind of what we see here, right? We have 1 here, and then a second 1 here, and then a third 1 here, and so on. And then a format specification starts with an identifier, optional arguments, left brace, statements, right brace. Makes sense, right? There's the identifier that identifies the format. Here are the statements. So the way that a parser generator works is that it takes our grammar and builds a really complicated state machine out of it. And the state machine has basically 2 operations that it can do. It can do a shift, which means to pull in another token. So here's our tokens, right? You can pull in another token, and it will do that by default if it can't do the second operation, which is called a reduce. A reduce is if we have a token sequence in our input that we've shifted in, and it matches any of our rules. So any of these rules, if they match, it will say, oh, I found a match, and it will take that and take all the values associated with all those tokens and then run it through this code. And the output of that, it attaches to a new symbol that takes the place of where the old symbols were. So you can imagine where shift, 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 and then whomp, reduce. Shift a little bit more, reduce that. Shift a little bit more, reduce that. And the final step will be to reduce all of the formats into one thing called the formats. So you can do whatever you want in these rule reductions, right? So what I do in my tool, and what a lot of compilers will do, is instead of just discarding the structure, it will basically interpret that structure. So this is interpreted to be a format with a certain name, a certain list of statements, and a certain set of arguments. So in a sense, we're making in memory a data structure, which kind of is like a tree. The root will be formats, and then the immediate children will be each format in a list, right? And each format will have some other children like the arguments and the statements. And at the very bottom are the elemental things like the these literal numbers and this literal string, right? That gets retained inside of the structure somewhere. So that's the second step. Taking the token stream and turning it into like this kind of data tree in memory. So the data tree that I make, if you traverse it in order and match it up with the input bytes here, that is analyzing the data and assigning a meaning to every byte in the input. So it's very similar to what Wireshark does in the data dissectors. So it takes this byte collection of bytes, and based on the position and the protocol that we're parsing, it figures out what every byte means. Yeah, I'm getting better at the recap because it's probably the thing I do most in the series, because every hour or so, someone new comes in and says, hey, what are you doing? Can you give me a recap? I'm like, okay, this is recap number 65. So each time I'm getting better at it. Eventually, it'll probably be like, what was it? I probably got like 50 streams into the game project or the web server project. And I said, okay, I'm getting tired of doing the recap. So I'll just record it as a video and then I'll just link to it and say, okay, I've said this so many times that I made a cool video that lasts a minute, and just go watch it and come back. So this tool, you can see it actually does run, but it's the old C-based tool, which I did for the first few streams here. I did go back and I made sure I could build it and it runs, and I like studied it to make sure I understood how it works, and I actually found and fixed some bugs that I think I documented some of this in my to-do list, right? I had this to-do list, and we did like figure out how to do something, right? Why do I get a warning? Figure something else out. Add something that we need. And here's a bug that we fixed, right? So after I got it so I could run it again, then I'm like, okay, next time, next stream, we're gonna start porting into Rust. Privileged to get a live recap and not some pre-recorded part. That's right. So again, 3 pieces: lexer, parser, and analyzer. So porting into Rust, start at the beginning. Port this lexer. The old lexer was using a tool called Flex, which is really popular, made in like the 70s or something. It's ancient, and it's basically a list of patterns, and if you match the pattern, it turns those characters into a token. So it's really simple for reserved words. If you see the letter I followed by the letter F, that's an if token. You remember Flex and Python? That's great. So the more complex ones are regular expressions, and there you have to do a little bit of extra code, because all that Flex does is it says, okay, yeah, these characters match this pattern. That's all I can tell you. And then what we say is, okay, now give me those characters and let me put it into a string, or maybe we call the A to F, which turns a string into a floating point number, or str to long, so turn a string into a long, like basically parse it as an octal or hexadecimal. So that's how it was in Flex. And then through a mixture of searching online and getting recommendations from chat, we picked the Rust, a really nice Rust equivalent of that, which is called Logos. So I'll show you what it looks like in Logos. Logos has a bunch of macros in it. One of the biggest ones is they have a derive macro for Logos, which generates the lexer for you, completely generates it based off of the other attributes you attach to your token type. So you define your own token type. It's usually an enum, just like it was for Flex. These are essentially these are essentially all like variations of an enum called a token, right? So here we're actually giving it a real type and same variations. So instead of like having a return to say what it is, in Logos, they are attribute macros. But it's the same kind of thing. If it's a bare word, it's just a token. If you need a regular expression, it's a regex. And then if you need to interpret after matching, then you pass a callback function, right? So identifiers are really easy. You just convert it to a string, you're done. Decimal's a little bit harder. You have to parse it as a F64, right? Base 16, it's even harder because we want to use from string radix 16, but that function doesn't like the X character that I like to put in there. So we have to like basically slice around it, right? So we extract the sign and extract the digits after the X, but we drop the X. Probably the most complicated one is where Sarian was pointing out that I used a complicated state machine for escape characters and strings, where I probably should have just used a regular expression. It just pick your poison or pick your evil, right? They're both bad. Manually code a state machine and regular expression, they're both dangerous foot guns that you have to do one of them, right? So this actually I did in 7 hours, so it was really fast. Now we're on to part 2, which is the parser generator. So it's again all of these grammar rules. This is what's called Bacchus-Nor form. So they are rules to recognize the semantic meaning of strings of tokens, and the meaning is we give a name to the meaning. So like list of identifiers, we give the name ID list. That's weird. I can't double click there. Now it's working. So given a name, then we give a sequence of rules, which if we encounter these sequences, we reduce it to an ID list. So a single identifier or a chain of identifiers where we're seeing the next one. And then again, these rule reductions happen over and over and over again and we shift if we can't reduce until we've eaten every token, right? So Bison, which is a GNU version of Yak, play on words and all that. Again, really, really old tool, generates C code. So I actually asked ChatGPT, what should I use if I want to take a Bison-based compiler or parser generator and port it to Rust? First it said nom, and then I asked it again and it said LRPop. And I looked at nom, I'm like, nom doesn't really work well with a lexer. It kind of does the lexing intrinsically. So we went to LRPop. LRPops. The LALR comes from look ahead, left, right, which is the parser technology based, it's like 50-year-old technology, and pop to make it sound like lollipop, to make it a silly name, right? So this is a little bit different. It runs before my program compiles. So it's like generating code that is added to the code I write before it actually gets compiled. So there are elements of Rust in here, but there's also elements of LRPop's own grammar. It kind of looks like an amalgamation between matches or switch statements, right? And the BNR, like the Bacchus-Nor form way of describing a grammar, where we have the name, and then we have an output, and then we have the rules that match, that if we match them, reduce to that thing. And the Rust code mostly goes inside of the what to do when we match. Similar to how the C code went into the rule matches for Bison. Bison had these weird $ things that the code generator would replace with real C code. In LRPop, it's actually pure Rust code. The names you get available, like this S, come from the non-Rust part, which comes before that in the rule itself. Even my worst design decisions are way too clear to be competitive in the international obfuscated code. Yeah, I would never win that. My attempts would be mediocre at best. So yeah, so this S means we're giving the name S to whatever the identifier is here, right? And you just have to look elsewhere to see that an ID is a token identifier, and attached to the identifier is a string. So this is actually almost Rust with the addition of this less than greater than. If we look at the real token type, we'll find it. That string has a string attached, right? Actually, that's not what I was looking for. I was looking for identifier. Go back. Not string. Is it up here? Yeah, identifier has a string attached, right? So we have to add brackets around that when we use it in LRPop. So this extern section is how we glue the parser and the lexer together. The lexer provides the token type, and we kind of have to redeclare it. And we put in like what the lexer would call it on the right-hand side. On the left-hand side, we put what we're going to use in the grammar rules. So that's up here, right? So ID, where were we? Where was I? ID here turns into identifier, a token identifier. And then we have a colon and something in front of it. We're just attaching a name to it so that we can use it in the context of if it gets reduced. Hey there, the EGL Omega. How are you? It's just explaining to Rally Monkey the recap and kind of where I am. I'm in the middle of porting my data analysis tool to Rust. And so I ported like a lot of the lower level grammar rules, like identifier lists and single optional identifiers, optional commas and look-aheads, key values and expression lists and expressions. One problem I ran into, the original syntax for expression was just a lot of rules, and the rules leveraged the fact that we could declare operator precedence. And if you don't know what that is, recall when you first learned math that if you say something like A plus B times C, that you always do the B times C multiply first, then add the A, right? But if I move the multiply to there and put the plus there, now you don't do the B plus C first, you do the A times B first and then add the C. Why is that? Because times has higher precedence than add, right? In other words, the higher precedence operator you do first, as if it had parentheses around it, right? And if you wanted to invert the precedence, you have to use parentheses and put it around the lower precedence operator. So in Bison, by the order in which you list them assigns the precedence. So we just talked about plus and multiply, right? If we list plus first and then multiply, and then plus gets a lower precedence and multiply gets a higher precedence. There's also the notion of associativity. So left associative means if you have like A times B times C, you do the left two first, and then that you'd multiply by C second. That means it's left associative. If it was right, then you do B times C first, and then you multiply by A. Most operators, in my language at least, are left associative. Some are right, and that's mostly because for assignment and accumulation, you want to evaluate the right-hand side first, then assign it to the left. Sadly, people still get confused with A divide by B times C. Right, so in my grammar, the divide and multiply are on the same precedence, and it's left associative. So you do the A divided by B first, then multiply by C. Some people will do the divide. Well, you're supposed to do the divide first. Why would you do the multiply first? Oh, you meant multiply first. Got it. So some people do the B times C first, and then divide that into A, which would give you the wrong answer. Yeah, they're the same. Although if you wanted to, you're perfectly free to define your own and do really crazy stuff like make multiply and modulo right associative and higher precedence than divide and make that left associative, and then you'll really be confused. Anyway, with Bison, we were free to let's undo this for a while until I get back to before I edit it. Yeah. With Bison, we just list the operators in order and we say it's left or right. So it turns out LRPop doesn't have that feature at all. So at first I had one huge expression that had all the rules, and I kept getting reduce shift conflicts, which are ambiguous grammar. So the solution that the LRPop manual talked about was to divide expressions into tiers. So you have the top tier, expression tier 11, and you can either have the lowest precedence operator, or you go down a tier. And you go down a tier and it's and, or you go down a tier and that's in. So that basically matches this or and in. Some other things to note: if it's non-associative, then both sides have to be the next level down. And look, there's a bug there actually. This should be an 8, and that should be an 8. Non-associative means like if you have A in B in C, it's a syntax error. So neither operand to the in can be another in expression, which is sort of obvious when you see this. If it has to be expression 8 on both sides, it can't be an expression 9, because you can't get from 8 to 9 without putting parentheses around it, as I'll explain in a bit. Left associative, like for this 10, you can have another 10 on the left, which means this itself could be an and, so you can have A and B and C, left associative, right? If I flip the left and the right here, if I had 9 on the left and 10 on the right, it would be a right associative operator, because you would have the compound statement on the right, and then you would do the left hand and that compound statement, right? So this goes down all the way down to expression 0, where we have a few extra special rules, which are that you can go back up to 11 if you put it in parentheses. This is the reset rule, they called it. So that's how you, like, when you say like A times, and you put parentheses, B plus, see, it's late at night. I'm going to mistype on my keyboard. These parentheses means in expression 0. So which is permissible on the right-hand side of a multiply, but plus itself is a lower precedence expression. Putting it down at 0 makes this the highest precedence. You add first, right? Highest precedence, and then multiply by A. So it kind of resets the precedence. So you have that, and then also I'm also sticking in here anything that doesn't use operators that could make the grammar ambiguous. So all the unary operators are unambiguous because there's no operand on the left-hand side, right? And they're all equal precedence. So it doesn't matter. They're all right associative by definition, right? Because there's nothing on the left. Also all the literals, literal integer, decimal string, and nil all fit in there. So yeah, that was the most complicated thing I've done so far. Other than that, doing the easy grammars first, and now you're up to date. So how many people fail online with stuff like 2 plus 2 times 4? That should be 2 plus 8, which is 10. People fail at that? That's like what you learn in elementary school, right? Yeah, with divide and multiply, it's left to right. Yeah, they're equal priority, at least usually. But again, if you want to, you don't have to put them on the same precedence, and you don't have to make them left associative. Do whatever you want in your language. So what grammar was I going to do next? Function call, right? That's what we were working on, right? So function call is here. Identifier, and then left paren, and then expression list, and then right paren. So identifier, and then we need a left paren. And then it was an identifier list. So, and it was an optional identifier list, right? No, it's an expression list, not identifier list. An expression list can be empty. Okay, expression list. So let's stick with simple expressions like 42, and then we'll have another one, comma 67, right? And then we'll end in a r paren. So that should parse as an expression of type function. And this is complex enough that we'll make it a type, I don't know what kind of enum you call it. The one with the braces and it has keys and values. So it'll have like a name, which will be foo, right? And then it will have args, which would be a vector of expressions. And that's it, right? So the expressions are going to be these two things turned into expressions. So paste that, let's get rid of the comma. And then token becomes expression. Like a type, and then this is literal integer. Because it's a little bit long, we will put them on different lines, right? Okay, and then that goes away. We need to define what function means, right? So let's go to expression and add function. When I hold down the wrong thumb shift key, I get an 8 instead of an F. Name is a string, and args is a vector of expressions. Now, you might be wondering, why didn't I box like I did here? The reason is a vector is a fancy kind of box when you think about it. A box has one and only one thing in it on the heap. A vector has 0 or more things on the heap. So that might not be obvious when you learn box and when you learn vec, but they're actually more related than you might think. So yeah, we don't need to box because it already is sort of boxed by being in a vector. Now, why did I have to box these at all? That was a few streams ago. The answer is if I don't, this becomes an undeterminately sized enum because you can have an expression, which is a binary operation, whose left-hand side is a binary operation, whose left-hand side is a binary operation, and then I can just keep going forever. So the size could be infinite. With a box, what is a box? It's really just the Rust version of a pointer to something on the heap. So, and it can't be null. So it's a non-null pointer to something on the heap. What that means is the size of this left-hand side is always just the size of a pointer. No matter how complicated the expression is, it's just going to be the size of a pointer. That indirection allows expression to have a known size without us needing to know what kind of expression the next level has. In a way, vec_t is box array t in a trench coat. Yeah, actually, because if I did that, when you think about it, this means that it's 0 or more expressions. This means it's on the heap. That's exactly what that is. So that's one of those things that when you first learn Rust, they're not going to say in any book or tutorial, that you just kind of realize later. I'm like, okay, they taught me about box, and then they taught me about vec, and wait a minute. They're the same thing, only box, the size of the vector has to be 1. Vector, it can be anything from 0 to whatever. Okay, so we've defined a function expression, and I have not put the grammar rule in yet. Let's do that. So just going to fit it down into the catch-all expression 0. I'll just put it here. So that was name ID for identifier, right? And then we had L paren. And then we had, for args, we had expression list. And then we had R paren, right? And that gets reduced to expression function. Where we have name and args. Actually, I guess I don't need to really fold that one. It's just a little bit long, but I'll deal with that with it being a little bit long. Actually, you know what? We'll just do this. There. That works too. Okay, and let's just run the test then. Hey, look, first try. Okay, but we did break 6 of our tests, and I thought we would, because these tests are all sensitive to all of the kinds of expressions that the first token of all possible expressions are printed for this error unrecognized token, because it says what the token ran into, and then in the expected, it lists all the possible first expression tokens. So what we did is we added identifier to it, right? Decimal flip, integer, left brace, paren, minus nil, not string. I guess that would be string. Yeah. Actually, why is it string? Shouldn't that be identifier? Did I mess that up? ID, right? Shouldn't have it said ID somewhere in here? Why is it string? Oh, because it could be a literal string, but ID should be in here somewhere. Still flip in. Oh no, that's what it used to be. Now it should be looking here. ID should be in that list. Yeah, right there it is. So yeah, we need to add ID to all the tests that catch negative conditions. So, like it said, right? They're all in expression 9, 0, and 1. Because that's just where they ended up. So yeah, right here. So, makes me think that I should probably have a global constant vector of strings that we can just reference everywhere. And then I would only need to update it in one place. Maybe I should go try to do that right now, rather than copy pasting everywhere. The reason why I'm not jumping to that immediately is because I think it might be a harder thing. It might take me a few minutes to figure out. So I'd rather just get the test to pass again and then start thinking about that. So yeah, expression 0 has 2 negative tests in it that do the same thing. Yeah, basically if you get an unrecognized token, then it lists all the possible ways an expression could have started. Depends on what language you're coming from. Sometimes it's different in a way of, in Rust, a constant pointer to a t is not equal to a slice of t. Well, yeah, because the slice of t has a size attached to the pointer, right? But in C++, pointer to t is equal to an array, wait a minute. Did you mean to type exactly that? In C++, that's true? I mean, that's true, right? In C? But that's not true. You meant that? But that's also not true. In this, you know, in either way, that or that implies you know an n. Here, there's no information in C++ about the n. All you have is an address. So that's more like this, right? Those are equivalent in C++. It's just you have some array, you don't know the size of it. Okay, but I still think that you don't want that to be t sub n. You just want a array of t, don't you? I guess I don't understand what you're saying with that. I'm misunderstanding, I think. 71 tests passed. Now, let me reconsider having this list repeated everywhere. What we kind of want is we want to have like a global static vector that we can just use in all these places. And we'd like to have it maybe at the top level tests, right? Like up here somewhere. So can we define like that? It's like with a const. And this is where I don't remember. The syntax in Rust is complicated for globals, right? If it's constant, we should be able to do this, right? Problem we get into is if it's not constant, then there's sharing problems. So is it the way that is this the way it's done? It's static const, or do we not have the word static there? Expected item. Static item is the value which is valid for the entire duration. Okay, so I think we just need const, right? And then we need some like the name. So it would be like, you know, it's usually all in caps. So like expression first tokens, something like that. And then we have to say the type, string, right? Thing is, I don't know if you can make a string or a vector at compile time. Let's see if it will let me do that. This I'm not too sure about. Hey, if this works though, that's exactly what we want. No. Allocations are not allowed in constants. It's because it's going to put it on the stack, right? So we need to describe it in a way it doesn't, I mean, a heap. We have to describe it in a way that the value size is known, and we don't need to run any, we don't need to put anything on the heap. So I think that would be, we're making an array, right? And these we can't do toString on. Actually, then it's like this. And I think we have to say the size there, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, the heap problem, right? Cannot call non-const function string as toString. So what if we just say static str, and then we'll just have to, I guess this is implied, so you don't have to say that. We'll just have to do the toString in all of our tests, right? So that we can use now in like x per 0, where we actually had that whole list. It's just that we'll have to like transform it into a vector. So that would be this dot iter dot map a slice to a slice. Well, there's a shorter version of this, right? Isn't this str toString? I don't know the syntax, so I'll cheat and do it this way. And then collect, right? Hey, look, that's exactly what we wanted. So that's the bummer, is that we had to repeat that all these places. But the good thing is that we won't have to update these now. We just update this list wherever, right? Once cell. You need one cell in static if it's mutable, but we don't need this to be mutable. No, you're just saying it correctly. That example was correct if they are parameters, but the other would be pointer to a constant. Wait a minute, let me think about that. Yeah, it's the pointer to a constant t, right? Is not equal to a slice of t. But in C, not C++, a pointer to a t is a array of t's. Yeah. C++ does not support array of t's. I thought C++ supported everything that C was in C. Am I wrong about that? And there were like the only exceptions to that had to do with reserved words. Like you can make a structure named class in C, but you can't name a structure class in C++ because class is a reserved word. And the Linux compiler uses that trick, I think, to this day to prevent kernel modules from being written in C++, which I think is a really funny way of preventing a language from being used. Okay. I like that we can just say it because we have use superstar. The use superstar, what that does is says everything in the top level test module imported here. So that it's like all the things that are common for all tests we get to inherit, or we get to reference, really. Okay, so we have two more, I think, right? One there and one here. Okay, and then this should just still work. And the one cell was for stuff like this, so you can do an alloc. Right, so that's like lazy evaluation when you need to put it on the heap. So oh, that's right. It's not for mutability, it's for initialization. The way I did it here, it can't go on the heap because it has to be computed at compile time, and there is no heap until the program starts running. So therefore, we can't actually make anything on the heap. But if you do a lazy initialization, that means it's not built at compile time. It's built at runtime the first time it's referenced. And there you use the once cell for that, right? Lazy initialize global data. So yeah, I could do it that way, or I could just have it, every test construct its own copy, right? Now this, if I wanted to use a function name there, I could, but it would be weird, right? Because it's part of a trait. So I'd have to say like string as, or slice as toString, : toString. Let's see if I can do that. So instead of s to string, it'd be like string as toString, right? Yeah, no, I got it wrong. Almost right. How do I fix that? Put that in front. There we go. So I think that's better than that, even though it is a lambda, because that's much easier for me to read than that. But they're equivalent, more or less. Or you just have lazy. So maybe I should revisit that to get more experience in using lazy global data. I should try to write this as a lazy. I kind of want to because I don't like the fact that every test is doing the iteration map and collect when it's run. It would be nice if you did it just one time. So maybe I will look it up. Paste. Oh, that didn't work. Oh, because I did open in new tab. I need to do copy link. There we go. Okay, so this is in the crate once cell, so we'd have to add a dependency for it. It would be better, you know, if this was built into the standard library, but it's not, right? So we would have to pull in the once cell crate, and we would have to say use once cell sync once cell, and then we'd have a static. No, not once cell, we would use lazy. Once cell sync lazy, and then we do static, our name, and then lazy. Do we always have to have a mutex? So even if it's immutable, we have to use a mutex? Or is that only to make it mutable in main? Maybe that's why I didn't like lazy. I think I don't like it because we have to have a mutex, and Why should I have a mutex for immutable data? I understand why. It's because you might have two threads simultaneously getting there first, and you have to pick one to initialize it, right? Need help coming up with a capstone project? Does anyone have any ideas? I'm bad at coming with project ideas. Do you have any parameters to that? What do you mean by a capstone project? Capstone project. Final assignment and plays a vital role in preparing students for the world of work. So what class is it for? Like a computer science class? Web dev or data data structures or algorithms? What class? Little sus. What class? You know what my next question is going to be? Have you asked ChatGPT yet? Because although you don't want to use ChatGPT to write the code project for the code for the project for you, you could at least consult ChatGPT and ask it for ideas. And then it just kind of sparks your imagination in how it answers you. It would like maybe give you 10 different ideas and you say, oh, I like number 7. Let me do that. Your senior project? Yeah, but for what class? You didn't like ChatGPT's ideas? You thought they were garbage? Okay. I'm sorry. ChatGPT has been doing pretty well for me when I need an idea and I ask it, tell me some ideas. Okay, we're gonna keep that because I don't like the notion of I already closed it. I don't like the notion of having to do a mutex for that. So we're just gonna leave that and move on. Okay, so then that means I refactored the expression stuff and we're going back to grammar rules, I guess. Yeah, we were up to function, right? So after function, we have literal map, map construction. Difference was these are expressions. See, again, that's not a literal map. Expressions can be references. So what was I thinking here? Let's look at my code. Like what was I thinking for literal map here? We evaluate the left-hand side and we get a value. We evaluate the right-hand side and we get a value. Oh, I had a special template for if we expect a certain type. Attempts to coerce the value to the given. Oh, it does coercion. Okay, so yeah, we can. This could be any type that can be coerced into a string. Oh, did you guys see that bug? There's like a really weird display bug there for a second. Anyway, that means anything can be a key as long as it can be coerced to a string. So that just makes a map by evaluating expressions. So what about that other one? Map construction. Where is it? Map construction. What does that do? Dereference keys and dereference the values. Is keys vector value. Oh, I remember this. Keys part index children's size. Oh, okay. The map construction would make a map from a part. So it doesn't work if it's not a part. I don't actually think I need this because I want in my language a part to be just, you could use it as a map. You shouldn't have to go through a map construction to use it. So this is like building a copy of all the values, right? Yeah, see, it goes through all the keys and it makes a copy at some point. Well, it does a coercion to get a key, and then here's somewhere it's going to do a value. Yeah, extract component value makes a copy, right? Yeah, clone. Exactly. It's going to clone the value. So it's basically making a shallow copy of a part. When I say part, by the way, what I mean is like header is a part of a GIF, right? So header will have how do I say this? When we're in the step 3, we're doing the data analysis and we're decomposing a GIF, header actually gets a value of a composite value. So we saw that when I ran this, right? Header is actually a composite with 2 parts in it, and it itself is a part of a GIF. So header, its nature is it's a 6-byte thing that has 2 parts, a 3-byte string and another 3-byte string, right? So I guess the original idea in my language is that you can make a map by taking the names of the parts as the keys and the values as the values, and then just make a shallow copy. Because it could actually be deep. Like logical screen is many levels deep, right? Logical screen has a descriptor, which has a width and a height. So that would all get collapsed down to just like logical screen width, logical screen height, I think. I think that was the intent, and I don't think I actually want that, because I'd rather make each part act like a map intrinsically and not need to make copies. So I'm inclined to like not even port this at all. So yeah, what happens if the value is like itself a part? It does extract component value using values part index children I. Where do we get all these things like I? What's I come from? It's the key number. Values part indexed children I. Yeah, where are we getting these keys? We're getting them from here. Oh, right, because we get keys and we get values from a map construction, right? Keys, comma, values. Oh, that's right. This has another effect of it can select a subset. So if we just wanted the width and height and not anything else, we would literally have references to the width and height, and then the values it would get from the header or the logical screen, and it would just go in there and pick the things we wanted out. Right? But it had to be a part? And that makes it even more limited in use. The left hand and the right hand side have to be both parts. They can't be literals. They can't be expressions. Well, yeah, they can't. Of course they can't, because they have to be reference. A reference always references a part, right? It's never a literal. And dereference turns them into values, right? Yeah, it's going to be the value. The values on the left are the names of keys. The values on the right are what the values are, what the map we construct, the values we're going to place in there. Yeah, this isn't really that useful to me right now. So I think I'm going to skip map construction, and I'm going to skip set construction because it's the same thing. And same thing for vector construction, right? I'm going to skip those, and instead, I'm just going to have what I have here, like literal vector. It's actually not even literal. It's vector, a vector expression. So we're forming a new thing called a vector. It's not even literal vector. It should just be expression vector, which is a vector of expressions. Yeah, that's what I'm going to do. So let's do this. Left brace key values, right brace is going to be expression map, and the map will have keys and values. I think I already did this actually, didn't I? Where did I do that? I remember doing this. Hey there, Kuros51. Here's my domain-specific language, by the way. Describe how to parse data. So like, this is a GIF file. To a human, it would look like that. To computer, it looks like this. And this language lets you describe like how to interpret these bytes. So first 3 bytes is a signature, and the next 3 bytes is a version. And this is how we described it, that the GIF starts with a header, and the header has a string called signature that's 24 bits long. We even have checks, and we generate errors if it doesn't match. Version, also a string, also 24 bits long. So my domain-specific language is how you describe the format. The tool uses that and walks in order traversal of the data structures that are compiled from this, and matching it up with the raw bytes of your input to spit out what the file contains, and it assigns meaning to every byte in one way or another, right? Grouping some bytes together because it's just a 3-byte thing, this signature. But otherwise, yeah, you should be able in my tool when I'm done to click on any byte and it'll tell you what it is. Like if you click here, it'll say that's the second character of the signature. If I click there, first character of the version number. Click there, it'll say that's the width of the GIF. There's the height. Yeah. Kind of like in Wireshark, the data dissectors do the same thing. You can click a byte here in Wireshark, or you can click a field, and these stay in sync. So this whole thing that's highlighted is the ARP request. And if you were to click like protocol type, it would just highlight these 2 bytes because that's where it is. Right? So I'm making a tool like that. Okay, so I wanted to see where in the grammar I saw this map thing. I added it at one point. I feel like you're gonna have to have that feature in your engine's editor. It's super useful. Like I wish that they had that in this binary editor, right? Wouldn't it be super useful if I could tell the hex editor that, hey, you can interpret that as a string? Right now you can't even do that. It knows it just says, well, like here are all the possible things it might be, and it happens to be that none of these are correct. If I click here, the UN16 and the IN16 give me the correct answer of 300, but all the other ones are wrong because it's too dumb to know how to interpret that, the bytes that are here, right? So in the end, you can think of the tool I'm writing is like a supercharged text editor that when not only does it show you the bytes and what it looks like if you looked at it as characters, but it'll also tell you what it actually means. If you click here, it would highlight the whole thing and say, that's the signature in the header. Or like too generic. Yeah, this is too dumb. It doesn't know anything other than that it could be a character and it could be one of these types, right? Okay. Getting really sidetracked. Sorry about that. I thought I had map in here somewhere. Maybe I just thought about adding it. Oh no, there it is. That's an expression map. A map from expressions to expressions. We're talking about a, oh, wait, no, that is a map. That's a literal map. So, wait, then what's the other thing in the other grammar, in the original grammar? Oh, yeah, we did that one. That's map. Right, so I'm going to skip this because I think it's redundant. Because that is map. This map construction is redundant. So next, that means the next one is going to be a set. Why do I have less than? Is map a reserved word? Less than parentheses is literal set. So I don't need this reserved word anymore, right? That's probably the only place where that word actually is present. Yeah. Oh, the less than and the greater than match. So it's like less than parentheses, 1, 2, 3, parentheses greater than. So that's a set. So also love to have an editor that understands ANSI control codes that are in the text file, but also don't have that, mainly using control codes for text coloring in your log file. Well, there's another reason. You might have a file that has console control sequences, and wouldn't it be neat if it highlighted that? It would say, well, this is changing the color to red. This is moving the cursor down. This one is erasing the console. Okay, I'm going to get rid of these keywords because we're not going to end up using them, right? Map, set, vector, and probably copy too. We probably put them in here and I don't need them. Yeah, these things. Let's get rid of them. These I'm not gonna need. I'm not gonna need copy either. There. They're gone. Let's make sure that I didn't break anything by doing that. I did. I broke it. Because I actually had a test case. I had a bunch of test cases. Okay, we'll delete the test cases because they're not valid anymore. Easy. Fewer reserved words means that they can now be used as identifiers. Woohoo! Okay, and then back to the grammar. We're going to have what I used to call literal set, but it's really just set. Okay, now I know what to do. In here, near where we have this, we're going to have less than L paren, expression list, which is values, I guess. And then R paren greater than goes to expression set values. There we go. Make sure that that is indeed what I had before. Less than, and then expressionist. Oh, there's optional comma in there? Yeah, we can add that. Why not? Optional comma. I'm down with that. Optional comma. Okay, so we didn't define anything new. Except for expression. Set. Expression. And set goes right here, right? So that's a vector of expressions. And let's make a test. I can close that one. I can close that one. Could probably even close that one. All right. There's map, so let's put set right next to map. Set. So it's LT token L paren. And then these are commas, right? And this is r paren token greater than. And we should get a set with a vector of expressions in it, like this, like a degenerate map. Cool. And let's add another test case for the optional comma, because we can. Set with trailing comma. So it's exactly the same, only we're going to add another comma here. Because we can. When our tests we added a new kind of initial token for an expression. It's probably that L paren, or less than, right? It's the less than, because that could be a set expression. So I do want to go back to tests, because we're going to add less than here. Could be the beginning of a set. Right, it's now 11 strings. Here's something, Rust designers. It would be cool if I didn't have to type that 11. If I could type in like question mark. It would be neat because, or underscore actually be more appropriate, right? Shouldn't the Rust compiler be able to figure out what that number is based off of the context at compile time? Is that too much to ask? Why do I have to count them? Isn't the computer better at counting than I am? Just saying, Rust people. For all I know, that is something you can do in the nightly build of Rust, and it's experimental, and I don't even know about it. I look forward to it being in stable Rust. Okay, next grammar. Vector construction. So what I used to call literal vector, so that's bracket. Expression list optional comma. Okay, so that's much the same as a set. Only it's L bracket. R bracket. So this is a vector. Like a set, but it implies order is important. Probably because the size is used before the expression is evaluated. Yeah, but it's all not needed at runtime. No, sorry. It's all knowable at compile time. Once you have the whole statement, you should be able to just look around in it. It should be able to look around. It should be able to say, okay, that's a whole statement. Now let's look around. That happens to be 11 elements, so that has to be an 11. In fact, if I do 12, don't I get a syntax error already? Saying, hey, that should be 11. Look at that. Consider specifying the actual array. Well, why don't you just do it for me? Why don't you just put the 11 in there for me? If it's going to be an error if I put anything else other than 11, why do I need to say 11? Why can't it figure it out? If 11 is the only possible answer that compiles there. That's my argument. If there's only one possible way for it to compile, the computer should be able to figure that out. And in fact, it does, because it gives me an error message telling me what it should be. Right? If I put like 0 there. Wait, why did that work? Probably because I have something else broken, right? Anyway, I'll get back to that. It was giving me an error message when it wasn't 11, so why doesn't it fix it for me? Just out of curiosity, what is my error? Oh, I don't have the. It's the build script failed because left bracket is not defined yet. Bracket. Technically, that goes after brace, right? And then we have the R bracket. Now we build, right? Yes. Except for I don't have that type in expressions. Let's add it. Just like a set is a vector. Okay. The error is probably later on in the compilation. Yeah, but I don't care. As a user, why should I care what the stages internally are in the compiler? The type system could hang out for a while and wait for that later stage and then say, get back to me when you know what the size is. Oh, it's 11? Great, let's move ahead. I think what that comes down to is it's hard. And so the Rust compiler team is like, that's pretty hard. Why don't for now, you have to know you have to put in a number and later we verify it's correct. Which is what makes me think that eventually they'll be able to log. Eventually you'll be able to fill in something like that once they solve that hard problem. And this will just work because that's how it should be. This pattern is everywhere else in Rust where you can have implied values or types. Why can't it work there? It would be nice, yeah. Can't wait for it. Okay, moving on. I don't have a test for this. It's just like set and set with comma, only it's vector. So we're just gonna like copy those test cases. And this turns into L bracket, R bracket. Set becomes vector. And first try. Oh, yeah, because we added another. So which means that's going to have to be at 12. Actually, let's be passive aggressive and leave it at 11. And then we can yell at clouds when it doesn't compile. It knows it should be 12. Why don't you just put 12 there? All right, cool. Moving on. Moving on. Again, skipping this other alternative syntax. I don't think we ever need it. I don't think I need attribute copy either. I'm going to skip that. So the only thing left then is reference, which we don't have yet. I have all the literals. We did function. We did all of the maths. Yeah, so reference is the only thing missing. So maybe we'll do that next. So what is a reference? Where are you reference? Here you are. A reference can be an identifier, or it could be a reference followed by an expression in brackets, which is a index, or it could be a dot with another reference, and that causes a reference chain. So this is an ambiguous grammar to LRPop, right? Because probably somewhere I had to give an operator associativity to dot. Yeah, left associative, right? So I'm gonna have to have like 2 tiers of reference to make it left associative. See, I'm learning, chat. Hello, tracking issue. Of course someone's already made it. Did Gelmega make it? Or is someone else? Oh, wow, it's been open for 2 years? Only 1 out of 4 tasks? Okay, do I have to like read something to find out what it is? Oh, here it is. Currently, Rust C supports type inference. That is, a function fn can infer the type of t based on its usage. Const generics also have limited support for inference, such as for arrays. We can infer n is a u size in some usages. In order to expand inference for const, it's necessary to lift the current specialized type ty infer into generic arg infer. So now we're getting into like the jargon of how Rust works internally. As generic arg covers both const and types, whereas ty infer can only be used for types, this eventually allow for consts to be inferred. That's exactly what we want. We want constants to be inferred. Seems to be a language quirk by now. What is const generic? const generic. So that's where you have a constant is a generic type argument. So you know how you're used to type arguments to generics, right? Well, this is a constant argument to a generic. So do I have an example? We can just look it up. Probably someone has made a great example for me. Rust const generic. Here we go. So you have a struct inner array, and then instead of a type here, it's a number. And that number is used to fill in the number you need to have for the size of an array. So if you want to make a new type that is a struct to wrap an array, you would use a const generic where at least one of your arguments to your generic is this actual size. So when you instantiate it, it would be like inner array int comma 2, and then that would turn into int semicolon 2. And when I first learned Rust, you couldn't do that, and they added that at a certain point. Did they say when they added it? I guess we could just ask Google, when were Rust const generics added? 1.51 released. It was a big thing. So it was 2 years ago. First version of const generics is available. Yeah, so they actually describe it again the same way. That's right. There was a first version that had some constraints in it, and then I think since then they've lifted some of those constraints, right? You always prefer the name value generics over const generics. I think the idea is that in the concrete type, it is a constant. Because it really wouldn't make sense to have a variable there, right? Types are constant by definition. I think that's probably why. Wait a minute, no. I know how to turn that logic on its head. You can say a constant, you can say all types are constant. Therefore, when you say const generic, it's ambiguous. Value generic is better because a type is not a value, but what you'd fill in for this thing would be a value. There we go. So I think I agree with the Gel Mega. They should call it value generics. But it is what it is. And let's move on. So I need to bookmark ref. Bookmark. And we'll keep that one, keep that one. Yeah, let's keep that one. Get rid of this one. Keep that one. Don't need this anymore. Don't need that anymore. Okay, good. Okay. So let's do it. Let's make a reference grammar. So test driven, I guess. We'll have a new module called ref. And then in tests, we'll declare it mod ref. Oh, ref is a reserved word in Rust. How about we just call it reference? And rename the module. ERENC. Okay. What can I copy? What can I copy that's not too painful? ID list is not too bad. Let's copy that. Reference, paste. Okay, here we are. Replace all IDs with ref parser. Okay, so we have like the identifier reference. So this will be a reference. I think it's going to be an enum, right? So this will be just identifier. Okay, and then bookmark that, go back to our grammar. The next thing a reference can be is it can be an index. Actually, the way I did it was there was just one type called reference, and the reference had an identifier, and it also had a linked list, right? It had two linked lists. It had an index link and it had a next link. So it had it was sort of a two-dimensional linked list. And the idea, right, I remember this. The idea was that indexing was a higher precedence than the dot. So outermost is you have a dot chain, and then everything in the dot chain was either just a bare identifier or it could be an identifier. Well, it's an identifier with 0 or more indexes, right? So our test cases could be just the identifier, and then an identifier with one index, an identifier with two indices, something dot something else, something with an index dot something else, something with two indices dot something else, and then something index dot something with itself an index. Yeah, I can. Okay, I'm already thinking ahead of how I would do this. So this is like one index. So an identifier foo, and then we have L bracket R bracket, and then this has to be an expression, which that could be if we support reference expressions, but we don't. So let's pick something easier. So token, right here, literal integer 42, because I like 42s. So that should give us let's just copy from here. That should give me a reference. See, all references will have an identifier in it, right? I think what it would be is a reference has an ID. It'll have a list of indices, and it'll have well, no, I need the outer to be a list also. So it should be a vector of references. In each reference, how am I going to do this? This would be a vector, I guess. And each reference would have an ID and an index, right? Indices, which this would be an empty vector. So the outer vector is the elements of the dot chain. The inner vector are the indices on every element of the dot chain. Okay, I think that's what I want. So then if I have an index, that means in the indices here, I put an expression, literal integer 42. Just think about how I would break this up. Since I have to manually format this, there's no bracket there. No, there is a bracket there. It takes the place of that brace though. And there's a bracket. Yeah, okay. Where's the break? Oh, I see. It should really be like that, right? So we don't have this integer yet. That's also should just be that. Yeah, we can import. Actually, why does it not let me do an import there? Weird. I have to type it myself. Okay. Maybe because we haven't defined what that means yet. Also, we don't have that, but we will. We will. We will have reference. Yep, so at the same level as expression, we're going to have a reference at this level. That we have to put in lib mod reference. Okay, and then this reference, we're going to define it. So struct, public struct reference. And just like expression, we have to derive debug and partially equal. Those are parser requirements. Okay, and we already said we're going to have a name, which is a string, and then we're going to have indices, which is a vector of of expressions. And then I just have to remember that a real reference in the grammar refers to a vector of these because it could be a dot chain. Yeah. Okay. I think we're good. Unless maybe I want to have two types, one that actually contains the vector. That actually might be a wise thing to do. So that would be this. So we would have a reference chain, and then this would be there's where we would put the name. No, we wouldn't put the name there. This would just be a vector. So this would be elements or something. Well, it would really just be a new type. Right? Do I even need to say that? I don't even think I need to derive code for it. Or maybe I do. I think you do, right? Because that is a new type. I kind of want this to be named reference, but I don't know what to call that, unless maybe it's like a reference part. Yeah, what if we call this reference part? And then we call this a reference. There we go. I did it. So reference is a vector. Problem is that we can't allow that to be 0. That's not a correct reference. But then again, the compiler will guarantee that there be at least one part. So I think it's fine. Good night, Delta Omega. It's 5 a.m. for you. Why are you up so early in the morning? Okay. So this really is reference then. But we got to change this, right? Because oh no, that was reference part. Shoot. But we also want reference. Because that goes out here, right? Because it's a new type. Those are all going to be compiler errors until I fix this. It's going to be the result is a reference. Now this should compile, right? With no OK, it is something. It's not optional. What's the deal? That should work. Cannot initialize a tuple struct which contains... Oh, there's a private field? Oh, that... I didn't know you had to do that. Interesting. Okay. Now what? I guess the... Oh, right. It's whether or not the parser gives me an error. Name? Actually, identifier is the correct term. So let's go to that and call it ID. That is a string. What's wrong with that? Field is private. Not anymore. Hi, Albert7H. How are you doing? Okay, this is getting quite long, so I suppose what I'll do is break it right there. Okay, so that's a single identifier, and then we have the one index version. Like this, right? With one extra parentheses because it's a new type. And then that compiles. Okay. Oh, I didn't want to click there. I want to delete all this stuff. Okay. Right, so more test cases. We have an identifier, we have one index, and then let's say two indices. So to that, we just add more brackets, right? There's no reason why these need to be on separate lines. Those kind of all go together. Then two indices is just two lines. And we'll have like another number there. And the idea is that all that should do is just add to the indices. Like so. Comma. Quick recap of what I'm doing. I am taking a tool that I wrote about 5 years ago that given some binary data that we can describe how it's formatted. You may recognize this format. It's how we do a GIF file. So here's lol slide, right? It's a GIF file. In a hex editor, it looks like this. And you can kind of see that the first three characters are GIF and the next three characters are 89A. The format says that a GIF starts with a header, and a header has a string that's a signature that's 24 bits long. It has to be GIF, otherwise it's an error. Next is a string, which is a version number, and it is also 24 bits long, and it has to be one of these or else it's an error. That's all specified in the really old document for GIF, which was made in 1987 and then revised in 89, where it says a header. Elsewhere in the file, it describes what the header is, but the overall grammar is specified that. So my version of that looks like this. So it's a domain-specific language that kind of describes data both structurally and functionally. So structurally, as in is saying the header and the logical screen are parts of a composite called GIF, but then how we parse it is a function. So we first parse the header, then the screen, then we have a local variable, and then we have a while loop, and we do a look ahead of 8 bits, and if it's 3B, we break out, otherwise we parse the data block and then repeat. Trailer always begins with 3B. So we run it like it's a function, but we're generating a structure that has the same composition that the function's executed in order. And so the tool that I wrote compiles this format description into a data structure in memory and then does an in-order traversal, matching it up with the raw bytes you give it in order to tell you what's in the file. So it's very similar to Wireshark's data dissectors, where you can click a packet and it will say, well, for this range of bytes, that's an ARP packet. And if you click anywhere here, like you were to click on the protocol type, it would highlight these 2 bytes. So that's the kind of thing I'm making. That's the hourly recap. So the fact that I can run it doesn't mean I'm done. It means that this is the C version that I made like 5 years ago, and I'm porting it to Rust. And I'm working on the middle part of the tool right now, which is the grammar of the format descriptions. So I'm working on the part of the grammar that talks about references. So it's like a reference in any other programming language. You have an identifier, and then you might have an index operation, and then you might have a dot and then another reference after that, because you can describe a path to get from the very top level down to some element, which is actually what we show in the report. That's a reference, right? Identifier, dot, another identifier, dot, another identifier. And then as we get down into like the structure, we can start to see that there are arrays internally. And at the very end, like we can see that data is itself a vector that we can index. So we're parsing these essentially. So like here's an example of a reference that has 3 parts, and the second part has an index. So that's what we're working on. It's 9:20. Good thing it's Friday. Happy Friday, everybody. All right. We have the identifier. So I guess we'll just call that bare identifier. And then we have 1 index, and then we have 2 indices. And then we should have another case where we have 2 parts, I think. 2 parts? How about 2 bare parts? So that would be like foo, and then like dot dig, no, dot. Foo dot, you know what comes next, right? Foo dot bar should be a reference with 2 parts. One is foo with no indices, and then another part, bar with no indices, right? That's what it should. This token sequence should construct this data structure. And let's throw in there like 2 parts with indices. So we might have foo, let's add an index to it. So that's one of these up here, right? The indices are like if after the name you have brackets, right? Let's have like 1 for the foo and 2 for the bar. So let's have like 12 and 34. And then we'll just fill in indices here. So like this. $12 and $34. Okay, what did I do wrong here? Oh, bracket there. Cool. So we still need to define the grammar. So let's go do that. Grammar. It's going to be a tiered structure, right? So we're going to have like a ref 1, which is going to give us a reference equals that. First, you'd like to say my format looks really interesting, but I need to ask the question, wouldn't a library handling GIF format be simpler? It depends on what you're trying to do. What do you mean by handling? You mean like showing it on the screen? Like, where was it? Can't find it. There it is. You mean just like showing it on the screen like that? I don't need that because I have it in VS Code. What I don't have is something that I can reprogram easily. So a library that would handle a GIF format to do something like show it on the screen or like tell me information about it would only work with GIF files. But with my tool, I can go in here and like code up some other format if I wanted. Thought it was supposed to generate gigs or GIFs. No, what it's doing the opposite. It's taking an existing GIF and breaking it down and telling me what the pieces are. So once I've made my tool and I'm done and I have a nice GUI, I can just start adding new kinds of formats. I can say, okay, now that we know how to parse a GIF file, let's go parse a JPEG and let's go parse an MP4. How about an MP3 while we're at it, right? And then the tool will be able to understand more and more formats. And I can even invent formats that don't exist just by coding them up. And I'd be able to use my tool to verify that if I made a file for this new format I invented, that it would parse correctly. It's like a generic decoder is what it is. So you're saying use a library it handles GIF specifically. That's a specific encoder. I'm writing a generic encoder, kind of like what you have for the data dissectors in Wireshark, right? Wireshark itself is not just for one kind of packet, it's for all kinds of packets. So it's open for extension that you can add a dissector to it to add a new kind of packet. So that's what my tool is kind of like. It's kind of like Wireshark, where I can invent a new format and just feed it a new format file to teach it how to parse it. Read the whole message, it will be clearer for you. Okay, let me read the next part, because you asked more than one question. And of course, your format is able to handle way more than GIFs, but then I wonder what would be the limitations and how you interact with this format to give the inputs and get your output. I've thought about a couple ways. One is sort of the same way Wireshark does it, where you would drop in a file, and the file would be a sequence of packets. In my case, the file would be whatever I want, whatever matches the format I give it. And then with a GUI, we could walk the data structure either through a tree or just by clicking on bytes. So that's one thing I could use this for. Another thing would be that I might want to write a script in Lua that takes advantage of the data structure as it's parsed and does things like searches for things in the file. So I might have a script that tells me how big an image is, and all it needs to know is the format, and I can add formats dynamically. All sorts of things I can think of. So what I'm doing is sort of like a reprogrammable and generic decoder engine that could fit into a lot of different apps. Does that make sense? And this isn't the only thing. It's not like I'm inventing something new. If you search around, other people in chat have pointed out that there already exist things like this. It's come up. It's an idea that's been done before. I'm just making my version of it. So I hope that answers the question. Again, this is a hobby project. It's not like we're making something new. I'm just having fun, ultimately. Yeah, why do we do hobbies? It's not to make new things. It's not to improve on something else. It's usually just to have fun and exercise talents and learn things. Okay, that's the way we described it in Bison. To describe it in LRPop, what happened to my grammar? Oh, it's right here. I don't know why I couldn't see it. Right, okay, so I'm gonna put that up next to I'm gonna put that right next to this so I can go between these two, right? So one rule is identifier. So we have ID is an ID that goes to reference vec empty vec for, no, not empty vec. It's a reference with one part, which is another post. That's a wall of text. Don't worry, I wasn't trying to shame remaking a wheel. You just seem very experienced to trust you that if you do that, it's either for fun or because you got something. Yeah, I think the problem is I answered your question inside out. So what I should have said is, on the outside, to answer your question, I'm doing it for fun. So digging in a little deeper, why is it fun for me? Because I could do all those things with it that I can't do with just a library that reads for GIF format. So probably would have been a shorter and more direct answer if I answered it inside out to how I did it, right? Because you got something you were not... No, it wasn't that I didn't have the right tools. It was that it's an interesting project for me. And the side effect is that it could be useful for other projects. Like I have worked on a couple different like games for just like seeing if I can make a game. And like, you know how when you write a game, usually you want to be able to, when you're playing the game, save the game. So you have a save game file. A lot of the time, your save game file, if it's a large amount of information that you need to store, you're going to store it as some kind of binary format. Well, what if you have a bug and you lose your save game because it didn't write it correctly or something like that? The tool I'm writing here could allow me to like peek into the structure of the save game and like spot where I made a mistake, serializing it, right? So it could be useful for that. There have been times where I've been working in a program that makes a serialization and it just looks like random bytes. And I'm like, I wish I had a way that I could just like parse that, like, or describe how to parse it and have a tool do it, just so I can see where I went wrong, right? So, partially I'm making this tool born out of past frustrations like that. Yeah. Of course, most people, what they would do is they, when they're writing the code to serialize, they're also writing the code to deserialize, and they would just debug it by running the deserializer and stepping through the debugger, and that's perfectly fine. Yeah, I just was thinking like this would be another way to do that, and I wouldn't need a debugger. It's also a great way to demonstrate how a file is put together, which is one of the uses of Wireshark, right? Wireshark is a great tool for teaching people how protocol stacks are formed, because it's like, here's a packet. Look, when I just click the ARP layer, it's this subset of bytes, because the bytes that came before it are the upper protocols, no, the lower protocols, because it's lowest to highest, top to bottom, right? And then the bytes that come after are the upper layers of the protocol, which are listed last. So it's a great tool for education too. Why is this not moving to another workspace? Because I'm pressing the wrong button. In fact, it is very flexible for everyone's situation. It gives it a lot of strength. I mean, that's why it's fun for me. Okay, so then back to the grammar. Right, so the way we parse this is it's just ID and indices is an empty vector. Okay. That should be enough to test the first test case. Bare identifier. The definition for ID? I thought I had one. Did I not call it ID? Oh, it's ID in parentheses. There we go. Okay, do it again. Something is not in scope. The word reference, right? So we have to like put a use for that. And this is not sorted, so I have to be careful about this. Yeah, O actually comes after a K, so that actually goes there, right? Use crate reference, and let's just be proactive, and because we know we're going to need both reference and reference part. What's ID syntax? This is for LRPop. Here, I'll put a link in chat. So it's a parser generator written in Rust. And there's a great link there. So what it is, it's a mix of Bacchus Norform to describe a grammar, and then Rust code to generate. So this is pure Rust, this part. And this code is emitted, it's executed if while we're parsing a file, we recognize this token sequence reduces to a reference. Oh, bloody hell. Meckers have gotten out of the box. There's one trick to this. This is not a Rust file. This is a LRPop file. The way LRPop works is you add a build.rs and LRPop looks in your project for all files that end with .lollerpop, and it processes them at build time. It actually generates more Rust modules that we could probably find if I peeked into the target folder. Let's look. That'd be the top level, right? Yeah, target, and then we have debug, and then we have somewhere in here our generated Rust code will be found. Let's close this for a sec. Where do you suppose it is? Under build? It's probably in here, right? Parser output. There we go. Look at that. So LRPop generates all this mess. It's basically indecipherable, and it's friggin' huge. So like it's a 71,000 line Rust file. It's the rough equivalent to what GNU Bison or Yak would produce for the equivalent grammar in for generating a C-based compiler. So it's a huge table state machine that walks through a look-ahead left-right parser generator. So we're never going to want to look at this raw. Here's the big data. Here's actually the table and the state machine table, right? How many states does it have? It's got 91 states. So if you have read the Dragon book, which is this, Compilers, Principles, Techniques, and Tools, whether you have the first edition or the second edition, they'll talk to you about how like one way to make a parser generator is the look ahead left right or the left right parser generator, and the goal is to make a huge state machine with a table where each row is a state and each column is an input token, and the cell in the table tells you what state to go to if it is a reduce, and if it's a 0, it's a shift. And I think a negative is an error, but I'm not sure about that. But yeah, it's gonna make basically an efficient way to reduce this grammar down based on an input token sequence. And if none of that makes sense, that's fine. You probably haven't studied compilers. You don't need to know how a compiler works to follow this stream, but it would help because I'm making a compiler basically. I'm translating the original tool into Rust? Yes. So the original tool was made with Flex and Bison. And now I'm moving to Logos and LRPop. Much more fun names. So what's the error that I have then? Oh, it was that I didn't pull in reference, right? Oh, it's also not called ref parser. It should be ref1 parser. Or actually, let's just call it reference. Or ref. Let's call it ref, and I'll get rid of the 1. And we'll call the other piece ref part. That's what I'll do. Yeah, this we'll just call it a ref. So that should make this compile, right? Yeah, and then I should be able to run this test. Because, oh no, we have an error. That in our grammar, so I'm not going to look at the grammar. I'm going to look at what generates our grammar to see what did I do wrong here. Expect an identifier for indices there. Oh, that's because this should say reference part with a brace and a comma is fine. So yeah, let's try that again. So how is your sentiment about Rust? Just in a few words. It is a fun and demanding language to use. I like challenges. So if you like challenges, you'll find Rust very fun because it's very hard comparatively to make a Rust program compile, especially the first try. But the rewards are that the language is very, very much like checking a lot of things at compile time for you that otherwise in other languages wouldn't be checked until runtime, if at all. So like it does all of the things you'd want, like bounds checking. It makes sure that you don't have two threads accessing the same data simultaneously and having a race condition. It makes sure you don't have memory leaks. It's very hard to have a memory leak, have a race condition, or have something go out of bounds and have it not get caught by Rust either at compile time or at runtime. So I didn't say it in a few words. Sorry. I have a hard time saying anything in a few words. So yeah, we passed the test. So moving on to one index. So this is going to break because we don't have a grammar for that. It's going to say it's an unrecognized token when we get to the bracket, right? So we have to teach the grammar about what happens when you see a bracket. So that's going to be a reference followed by a bracket with an expression in it. So that means we'll have to have a part, right? And I actually have to move that into ref part. Yeah, actually this whole thing has to be moved because this is actually ref part. And a ref can be right now just a ref part. So a ref part can have another ref part before it, which is the reference. I'll just call it R. Ref part, followed by an L bracket, followed by an expression, which we'll call the index expression, and then R bracket. So that's going to generate I'm actually thinking this shouldn't be referenced, but I'll fix that in a minute. Yeah, anyway, actually what I want to do is take that R and build off of it. So let's do that. This should let me do that, right? It gives me an owned copy of it. So I can say R dot indices extend, no, push I, and then return R. So I think that will work if I remove that. So let's try it out. Try the first test to make sure I didn't break it. No, I have a bug. Ref par should be part. Where did I say that? Here. There we go. Don't want to waste my time. Well, thank you. Just remember, one of the reasons why I stream is I want to get better at balancing work with interaction. One challenge interacting with people whose only way to communicate back is through writing text is that I don't get any of your body language. And so I think there's a natural human tendency to keep talking until you get feedback. And if it takes people a while to type, I'm going to tend to over-explain and say too many words. I'm trying to improve on that, which means I should say fewer words and wait for your feedback. And maybe you say, continue, and then I'll say more. Okay, we have an unknown field indices. Did I not name it indices? Oh, I know why. Because we said that it was a reference, not a reference part. So that's where I need to change this. I think this has to be this actually has to be reference part at this point. So we're going to collapse it a bit like that. So then Now it should work, but that means I have to move what I had up here. This has to move to here, right? And that means we have to actually give it a name, R, because R goes there. Okay, and then this can go back to reference part the way it was. Okay. Let's try that. I'm getting there, slowly but surely. Oh, I have to put the word MUT in front. Yeah, I had to do that before, right? And I forgot. Yeah, we're allowed to put that there, and I guessed that last time. That. Kind of like in Rust. Could be a bit like that. Sometimes tend to have the same concerns. Yeah. It's much easier when chat is slow, actually. What gets me really nervous and anxious is when chat is going really fast, like after a raid. And then I kind of feel like I have to keep up, and it just becomes overwhelming. All right, so what's the bug? Panicked at assertion left equals right. Oh, foo bar, that's wrong. This should be foo, right? Or should I just say foo bar? Try again. Why did it panic? Shouldn't it have just said fail? Oh, okay, pass. 2 indices test. This is where it's going to fail, right? Oh, it's the same problem. I named it foo. It was inconsistent. Then it becomes consistent after that. Okay. 2 indices test. Actually, this should work because we're doing a push. Yeah, so any number of indices would work because of the way we wrote it. And then this is the one that won't work because I don't have syntax for it yet. Yeah. So it's going to say that the dot is unrecognized because we don't have a rule for that. And that's up here, right? So it's if we have an existing reference, not a reference part, because we want to do a left associative operation, really. Dot. And then the right-hand side is always a RP, I guess we'll call it, ref part. Or we'll call it next, maybe. Yeah, and then that's gonna, we're gonna make this mutable because we're tacking on the reference part to the end of the reference. We're saying r dot, well, it's just r, right? Actually, if you do a new type, is it dot zero? I think it is, right? To be r dot zero dot push next. I think that's right, and then you just do r. Let's see if I got it first try. Nope, because it doesn't know what dot means. Because I didn't teach it that dot is a special token. Dot. So this is the glue between the lexer and the parser, by the way. The parser knows it as the dot string because you're not allowed to use variants of enums up in this syntax. You can only use constructs or terminals. Your terminals are your tokens, and they have to be strings in the grammar. And in this special extern block, we do the mapping between terminals, symbols, and tokens. Okay, so run it again. Oh yeah, I missed a semicolon, and it's very helpful. It told me that I'm missing a semicolon up the top here. Right there. Thank you, Rust compiler. Hey, look at that. We passed the test. So we'll probably pass the next one too. In fact, we're probably going to pass all the tests. And if I did all the library, we pass all 80 tests now. I just noticed that your name is the G-Man Rocks. Thank you. Silly reactions that they added to macOS. I just revealed what operating system I'm using, by the way. The fact that I can... Come on. This should work. There we go. The thumbs up. Because, yeah, I'm actually on a Mac Studio, and this is running in a VM on Parallels. If you didn't know. And yeah, the latest version of macOS added that goofy thing to cameras. Okay, so we're done with references. That wasn't too bad. Compare that to the original, where it was one syntax with 3 rules because of the inability to say that that's a left associative operator. We had to do it with 2 tiers. And that's, again, this is how you do a left associative operator with 2 tiers. It's self-referential on the left, and then the next tier down is on the right. It's built in? Yeah, it's the default. Should have been a virtual camera out of this? No, it's not a virtual camera. Ask anyone who has a Mac who installed the latest Mac OS. If they go on a FaceTime call or they go on live on a stream and they don't turn it off, then every time they do one of these, they get the fireworks, and yeah. It's just a thing. It's one of those features that they added. Okay. What was after? Oh, expressions can have references in them. I think that was the next thing, right? That was the last part of what an expression could be, is it can be a reference. Down here somewhere. There we go. It's an attribute lookup. So it's a reference expression. So let's go to expression and add reference. And I think I have to box it. Otherwise, it's an infinite size structure. In fact, let's try it, and it'll probably tell me that. Yeah, you know, actually, a lot of people didn't know that those reactions were added. And like they're surprised the first time that they accidentally do a gesture that gets misinterpreted, and they're like, "Oh, how did that happen?" You know, how did I make that happen? Okay. We told about it there. Let's add it to the test. Let's add a test case. I guess we'll put it here. So this would be reference. Simple. So we just have to have some kind of reference, right? Actually, how will foo and how will a reference and a function be disambiguated by the grammar here? Because an identifier could be reduced as a reference. I guess it's the presence of a left parentheses will disambiguate it, right? It'll look ahead one more token when it sees identifier. And so if the identifier is followed by a parentheses, it knows it's a function. If it's not followed by a parentheses, it'll reduce it as a reference. So this should be fine then, as long as it's not followed by a left parentheses. So if we just do that, then it should show up as a reference. And the reference has a ID of string, right? I think it is. And then, oh, reference is a new type for a vector, right? Of reference parts. So then we have a reference part. Hey, Darly Quack, how are you doing? we're reporting. That's fine. About once an hour or so, or maybe it's sometimes more frequent. People come in and they need me to give you the recap. So really, really fast recap. Let's say that I want to dig deeper into a certain kind of file format. For example, I just picked arbitrarily GIF file format. The familiar GIF images that can animate, right? So to a computer, it looks like this. And if you look up online, you'll find like this is the grammar for a GIF file, is how it's constructed. There's a header and a trailer in between there. There's a logical screen and a data. So I'm working on a tool that you can describe in a certain kind of custom-made language how to look at a GIF file and pick it apart, all its constituent pieces, and it will look like this when you run it. Well, one way it could output it would be like this, where it says, well, those first 3 bytes, that's the signature of the header. Next 3 bytes is the version in the header. And you can imagine the applications of that. For example, the Wireshark's data dissectors do this. If you say that the thing is a packet or a protocol stack inside of a packet, then it could figure out what the bytes mean. You can say, well, that region of bytes is the ARP protocol, because based off of what the other bytes around it meant. It's all contextual, right? Same thing with mine. As long as your outer format can describe like what parts are in it, then like, yeah, the first part's header. The header has a 24-bit string signature, 24-bit string version. So it's just like the protocol dissectors in Wireshark. Only I'm just making it for fun. Also I'll be able to use this for maybe other projects where I either want to learn about a format or I want to have like some kind of tool to study files in case they like maybe I'm making a game and I have save game files in their binary format and I want to be able to like debug them really quickly or glance what's inside of them. A tool like this would be really useful. So I already, like I showed, I actually can run it. So it's done, but I wrote it in C 5 years ago. And just for fun, I'm taking the tool, porting it to Rust, and then adding some cool like user interface stuff to it. So the tool's in 3 pieces. The first 2 are the compiler. So there's a lexer and a parser generator. And the third one's an analysis tool. So I did the lexer, the front end of the tool. It makes our program here into a sequence of tokens, right? It says that those first 3 letters form an identifier, and then there's a brace, and then there's a header identifier, semicolon. So that's the lexer. We did that. I did that like a week ago. I'm working on the second part, which is the syntax of the language. So originally it was described using GNU Bison grammar rules, which generate C code. And now I'm turning that into the equivalent in LRPop, which is a Rust code generator based off of similar kind of syntax rules. Yeah, you got to catch the audience up on the hour. I usually start the stream with a recap, just in case anyone is loading the VOD. They'll start off with a recap right away. And then as people come in and they're brave enough to ask me, what are you doing? And then I'll give them another recap. Hopefully it's not too boring for the people who've been watching for a while. And I have a tendency to talk too much. I'm working on trying to make my recaps shorter and then rely on your questions if you want to know more. If I use too few words, though, you might be like, I didn't understand what he said, so I'm going to go watch some other stream now. And that would make me sad. Okay, I was working on, I have the grammar for a reference. And by the way, these that we were looking at before, these are references. So it's like in C, where you have like a nested data structure. The outer one is GIF. It has a part called header, and a header has a part called the signature. So this is a reference. It has 3 parts, and the dots separate the parts. And then another kind of reference maybe at the end is this, where like it's also 3 parts, but the middle part is actually a list, and you can index the list to get an individual thing out of it. So I'm representing that as the overall, there's a reference which has parts. Actually, it'd be better to show you the data type here. A reference is just a vector of parts, and the parts are separated by dots, right? And then a part is a name with 0 or more indices, and the indices are any kind of expression. So they could be a literal number, or they could be another variable that we have to look up to find out what index to go into. That's what a reference is. So yeah, this is the test code. So we form like test cases where we say, given this sequence of tokens, this is the result of parsing that. Wonder, doesn't it feel a bit small to code like? What? And we're used to having multiple files shown. Well, I'm using a big font because I'm streaming and I don't want it to be unreadable by you guys. If I was doing this on my own and not streaming, I'd probably use a font that was smaller than this. Like, I'd be able to fit twice as many rows, and I'd certainly like it to be wider. I'm actually not using all of my screen. I'm using about half of it. I have an ultra wide screen, but I want to stream at a standard resolution, and I want to have room for my camera and then the chat up there. So I'm kind of constrained with that just to make it readable for you guys. Is the cat wants in to eat? There's a cat at my door. So yeah, I'm doing it for you guys so you can read. A lot of streams will like whoever's streaming won't care about how big the text is, and it'll be super small. And I tend to like not watch those streams for very long. And then I think, well, if I did that, that would happen to me. People would come into the stream, wouldn't be able to read the thing I'm doing, and then they would just leave because there's nothing that captures their attention. With this being large enough on your screen, then maybe you don't leave so quickly, and maybe you stop and ask me a few questions about it. If you want people to be able to read your code, you gotta like the 60%, yeah. And the same thing with these browsers. Like, I can't really blow that up very big, but this text is much bigger than I usually have it on my screen. So expression reference, and then reference is a new type holding a vector of parts, where the ID is that and the indices is another vector. In this case, it's going to be empty, right? Because I'm trying to keep it simple. Well, that's a lot of parentheses. Okay, so we don't have reference, so we're going to pull that in up here. I need to let my cat in so she can get to her food. Hold on a sec. Want to eat dinner? Rust or Lisp, who can tell? This is all Rust, but with macros. Whenever you see this, it's an attribute in Rust, and user-defined attributes are one kind of macro. So that's where it gets a little bit funky, because this doesn't actually have to follow Rust syntax. It could actually be anything you want. One kind of attribute I've seen is you can write HTML in here and it turns it into Rust code that generates HTML. It's pretty wacky. Too many parentheses? Yeah. Good thing I have this plugin that shows the colors, so I can visually match up and see like that pink one goes with that one. And then like there's the blue one, and then the yellow one's in there, and then there's the pink bracket, and then the brace. The cat would rather have me play with her rather than stream. But I love you guys too much to like just abandon you. Reference part. So that was down here. Here. Let's run it and make sure it works. It's not going to work, right? Because we're doing test-driven development. It's going to fail. It's going to say it's an unrecognized because it expected a left parentheses, right? It only knows about function calls. So let's teach it that another kind of expression is a reference. In the grammar, for expression 0, we can say that it doesn't have to start with the parentheses if it's just a reference. Ref, right? Ref. If it's just a ref, then it is an reference expression. With R. Actually, I thought we would get a infinitely sized structure when we did this. But I guess we don't because this internally boxes everything. Right, because everything's a vector. So there's indirection through the vector. Yeah, I have to box when I have expression containing expression. Otherwise, it's an infinitely recursive structure. Show the cat? Okay, I'll show her if she wants in it again. These days, I haven't shown her on stream that much because she tends to try to get my attention by doing bad things. Like she'll go behind the green screen and mess around back there. Oh, I see what you're saying. Rust or Lisp because of all the parentheses. Yeah, if I was coding in Rust, it would be like this, right? Ah, yes. We all know what that means. That is looking up a web page and deciphering it as and loading its CSS and yeah. It's like it just looks like a bunch of parentheses to me. That's why you always box your structs to prevent the infinitely recursive struct from swallowing the universe. Yeah, don't worry. The Rust compiler will save you from the universe being destroyed. Typical cat pushing things off the edge and stare at the owner. Yeah. My last cat, I didn't have to worry about this, but I'm learning now. My cat was a saint because the new cat we have now, the moment you don't do what she wants, she knows exactly what is on the list of things that are naughty, and she'll just pick one. Oh, I'll just pick naughty thing number 3 to do right now. He hates that. He'll definitely pay attention when I do that. Yeah, that's what I'm learning with our new cat. Yeah, my old cat, I actually have an enum for him. The Beast. Yeah, he passed away. He was really old. He lived a long life, and he is never naughty, and that was very unusual for a cat. I don't have an emote for the new cat because I'm no longer an affiliate, and so I can't make another emote, I don't think. Have you seen that Netflix documentary called The Mind of Cats? No, I haven't. Would that be very applicable? Oh, let's run the reference test. I keep stalling. This should work now, right? Unless we have a recursive grammar. No, it just works. It took a while for the grammar to get built. That's all. Let's run all the tests to make sure we all pass. Cool. That means I think expression is completely specified now, which is awesome because that's a huge part of my grammar. Is reference and expression. We cover everything now. All the kinds of expressions are captured. So now we can start building up to larger syntactical elements, right? We have expression. We have optional expression list key value, Key values. We did reference. Okay, so here's one thing we can build off of. So it's the interpretation of data. Could be just a semicolon, or we can have an L brace, key values, optional comma, and a right brace. Yeah, this is usually the last thing in a part statement. And so far I haven't actually used the alternate syntax. So like the alternate syntax for here would be, instead of a semicolon, we would have an interpretation. And what are we allowed to do there? I'm losing track of my tabs. Key values, and then maybe an optional comma, right? So the key values would be anything I want. So it would be like foo bar 42. So that is a valid syntax still. I could run this and it still works, right? But if I broke it by doing that, now if I try it, it will fail. Syntax error. I believe if I remember right, when I designed this 5 years ago, that interpretation key thing, it was meant to like the value of header. It would look up in the table and find the corresponding key, and then that would become the that would become the overall value. So like, actually, let me see if I can do that for something that makes more sense. Like if I said that we return the version, right? Normally what that would do is it would put the version number on the header, right? But what if then I interpreted that version to mean like 87A means 1987 version, and 89A is the 1989 version. So I think then when I do this, it's going to actually, oh, I didn't do it. I think what it was meant to do is turn this into that when we print it out, but I never got to that here. Why don't I keep that for now? Anyway, I think that's what that was for. Represent possible values the data interpret, and the corresponding values are the interpretations. And I don't know why I go so much into detail about the optional comma, but I do. So yeah, where does that interp go? Okay, it goes for a statement body. If it's a part description, it gets stored here. Now I'm kind of curious what actually happens to it later. There's where it gets destroyed at the end. There's where we declare it. Optional value interpretation map. Is that it? I never use it. Can we exclude Google test? I don't care about Google test. Can we, I have to have a comma, I guess. Let's ignore Lua. Oh, I use it here. That's parse format. Okay, I built that, right? So I can run that. That's build parse format stage.gif.fmt less. Version. There we go. So that's being printed because of this. Or not that. This. That's that. Okay, so it's used there. Where else is it used? It's used. It's not. That doesn't count. I should do like whole word. There we go. Okay, so that's the only place where it's used right now is to print it out. So yeah, I was going to use it for more things later, but it's not used for anything else but literally there. Literally right here. That's the only place we're actually seeing the interp dictionary. Okay, well, we'll carry it on. We'll keep it going. So then it's a new thing we're going to test, so let's add it. Collapse everything. What decision has affected you the most in life? Nightshade dude, yeah, you are 2 hours and 36 minutes late. The decision that's affected me the most in life? Probably it was deciding which college to go to. Because that set forth a chain reaction that led me to the friends and family that I have, and also the job and the career path that I went down. Can I restart? Yeah, it's called you go to /videos and you start watching the VOD, Nightshade dude. And then another way is there's another secret URL called the time travel option where you click it and actually you go back in time to 2 hours and 36 minutes and you're able to talk to me in real time 2 hours ago. But it's such a secret URL, Nightshade dude, that you have to have a very specific version of a very specific web browser, and figuring out which version of which web browser is meant to be so difficult that I can't give you any hints. You're just going to have to find the browser that supports time travel. I know. That's a good guess. But unfortunately, you need a time machine to even get to Netscape Navigator. Okay, I'm going to add a new unit test first. Test-driven development, right? So where am I? I'm here, tests. We're going to add something called interp. So which means the test has to declare it. Okay, and then interp is going to look a lot like what? An optional something, right? It's either semicolon or it's something complicated. So it's official. I now have too many tabs. I can't find what I'm working on anymore. The optional comma is a really nice one to start with because it's so simple. It's got a lot of error cases I don't really care about, but I won't hold that against it. Okay. Op comma becomes interp. Okay. Then we have like just none, which would be semi colon. And then we have like some, and that would be left brace, right? Close that. Semicolon or left brace, key values optional, comma, right brace. Okay, so then back to close that here. Left brace key values, so that would be like a key, like, yeah, let's just make it simple. Foo, and then like token colon, and then token like literal integer. for going to a small college, it's going to be more convenient and financially possible. One thing I've learned about decisions that affect you in life is that you'll never know how impactful your decision will be until way later. You'll think back and think, wow, if I had just turned left instead of right there, I wouldn't have gotten into that car crash, which led to losing my leg, which led to me being, going through therapy. So like, don't try to like anticipate the big decisions. One philosophy is to just treat every day like it's your last, and then make every decision like an honest, truthful like way that you want to decide. And then just everything is an impactful decision, and you take joy in everything you do. Literal integer. It's not. What's wrong with that? It's getting late, and I think I'm just forgetting the names of things. It's just integer. There's no literal was for expressions, right? So then we have to end with a R brace, and this is all indented, right? What do you miss and don't miss from programming in the 80s and 90s? You know what I really miss is the sound of a dot matrix printer. What I don't miss is how slow it took to actually print anything out with it. Isn't that funny? You can both miss and not miss different aspects of the same thing. I miss the sounds the floppy disk drive would make. I don't miss how slow the damn thing was and how unreliable it was. Interesting thing, like computer games back in the 1980s, you knew you made a mistake in some games if the floppy disk drive started to spin, because sometimes it would happen first before the feedback from the game. The moment the disk drive spins up, one of your characters is about to die. So if you were fast enough, you would flip open the drive door once you like get that that feedback that this drive is starting to spin up, and then you'd avoid your character dying because you just open the drive door. It can't write the fact that your character is dead, and then you just reset the computer, and then you're back to like maybe the beginning of the fight you were in. I miss stuff like that. Nowadays, like when you're playing a game, there is no disk drive. There's no sound to like, there's no extra hints that the game designers didn't think about that you got with those old games. Like, here's another thing. Actually, here's something that's still true that had fun talking with friends about. Do you know in Baldur's Gate 3, when you there's a certain point in the game where it says you're going from Act 1 to Act 2, right? And it actually has to pause and load. That reminded me strongly of old games where when you get to a certain point in the game, it said, insert disc 2 to continue. And that was always your clue that I've now gone from one area of the game to the next area of the game. And if I missed something on disc 1, I should probably go back and finish it before I go through that door that says insert disc 2. Same thing in Baldur's Gate 3. You get to the point where you're going from Act 1 to Act 2, and if you haven't completed all the quests, you're like, let me go back through that door to Act 1, finish those quests, then go to Act 2. So I miss little things like that, like turning the disc over when you go from one area of a game to another. Nowadays, in most games, that's just completely gone. Except for that one example, Baldur's Gate 3. There's a definite switch from one act to another. I think it's because the game is so damn huge that they just can't fit it all in memory at once or something like that. I don't know what it is. Foo colon 42. Yeah, so this is not an error. This is going to be an okay. Oh, we have to fill these things in too. Let's have an option. So this would be none, and this would be something. as implied by the names of the tests, right? So the sum, it's going to be a map, right? So that would be what data type am I using for map right now? Vector of key values. Perfect. That's what we'll put here. The disk swapping is gone. The load times aren't. What's the expression? I can't think. It's too late in the evening. I hazard to disagree with you. That's not the way you say it. I think we could debate about that, Gnarly Quack, because just try going back to like a really old computer like an Apple II and then experience how long the load times were back then. Sometimes on some of those games, every time you step, it would have to spin up the disk drive for a second or two, and then you'd actually step. It was horrible compared to today. Yeah, you could actually, if you do an authentic emulation of some of these old games, it will actually put in pauses on purpose to emulate how long it took the drive to spin up. And some games actually broke because the game designer would bake in delays based off of how long it took for those physical parts of the computer to actually move. And now that they're emulated, they actually don't play with the right cadence, or like the sound is off, because the hardware took enough time that they baked that into how the game worked. Okay, some key value what? Oh, this is the type. We actually need a value, so it would be vector, right? And the vector is going to have a key value. Sure, use, and that's, what does that look like again? It's a struct with a key and a value. Key. Types. It's been too long. Expressions. Okay, so this is expression. This would be a reference expression at this point, right? Yeah. So maybe let's not use it because that's going to be too... Well, I know we can do it. We can do it. A reference, and then we're going to have a value, which is another expression, which is... This is the easy one. This is a literal, and this is where I was typing literal integer before, because a token integer becomes a literal integer once it's parsed. He was never on an Apple, you gamed on an Amiga. Apple, Amiga, same thing, right? Too young to appreciate being on an Amiga, though? You only code Rust in your free time? Yeah, only for my free time. I don't do Rust at work. Yep. That's one of the reasons I do Rust on stream, is because I don't do it for my work. So completely avoid the conflict. Reference. So this has to be a vector of parts. And we're going to have one part. So we have... Oh, this has to be... the type has to go here. Reference. So in here we have a reference part, which has a ID, which is this. Indices. Empty vector. Okay, I'm almost there. I'm getting myself into trouble using these complex types, aren't I? Okay, what's the problem here? Mismatch types. Why did it expect a unit type? Because that's unit. So instead we're going to expect an optional key values. Right. Right, it's key value vector. Yep, and then we can get rid of these test cases that we don't need anymore. Expression, actually we want to import that. We will allow that. Automods prude. What's the programming like at work? I can't talk about work. That's one of the conditions of me being able to stream. Can't talk about work, can't do games, and can't check things up into public GitHub. Can't do open source. No open source, no games, can't talk about work. Yeah, I did F up, didn't I? This only is a red squiggly because I haven't written that yet. But I done fixed it, right? The problem was that I didn't have the right type here. So once I put the right type there for the expected output, then this actually matches a vector of key values. There's one key value in it. And does that imply that we could have an empty vector? Actually, I guess we could, right? So I should probably have a test for that. So this would be like, that's something. And then like empty. How about some empty and some non-empty? So this would be, there's a brace, but there's nothing in it. So that would be, there is some vector, but the vector is empty. Yeah, I think that's what we want. No open source, no. Curious what the restriction is about. It's just a policy. The company I work with says in order to contribute to an open source project, you have to get it okayed by a bunch of red tape. And it requires approvals like up and down your management chain. And it was basically impossible because it would, like, I've heard that some people wait years before they get approved. And the problem with doing live coding is that you're constantly making contributions. And so I'd have to like basically get every stream pre-approved. This stream, I'm going to write this code. You know, make sure it's not a conflict of interest. And they say, okay, you can do that stream. Okay, next day. Okay, now this, I'm going to do this more code today. Could you please review that? That's the other thing is they have to review the code before you submit it. So like, how can that be if I'm writing it live? Yeah, it's just not worth it. There's plenty I can do on stream as long as I don't do any game dev and I don't post this on GitHub. It's not open source. I'm letting you look at the code, but the code does not have a low open source license. So technically, if you were to copy this from the screen and you made your own copy of this, you'd be violating my copyright. Coding in different language mitigates all that? No. I still I can't make a game in Rust, and I can't do Rust open source. I also can't talk about, I can't write something in Rust that use it I can't talk about something I did at work, even if it was a Rust form of that. It doesn't mitigate on any of that. You get carte blanche with Prime, which sounds like it won't happen. Well, Prime works for Netflix, right? And I guess Netflix is a more open-minded company as far as open source goes. There's just some companies that are kind of weird about open source software, right? They're like very nervous about there being a conflict of interest. Also, think about it. If I gained a reputation through my open source code, and that reputation was not so nice, that could reflect poorly on the company too. If I were to talk about the company and do open source at the same time, they don't want to get involved in any of that. So they're like, don't talk about it and don't do any open source code without getting permission. Then there's no problem. Maybe if they were not so worried, it'd be better mood to spend, what's this? You'd be in a better mood to spend time with what? Did I miss something? I missed something. I didn't understand the last thing you said. Red, he left you. Okay, this is ready to go, except for we haven't actually made the grammar for it. It's 10:30 p.m. How late do I want to be coding? Until I lose my voice? It's been almost 3 hours, maybe another hour. That's probably enough time for me to lose my voice, right? Or you're being silly? That's one problem about writing in text only. It's really hard to get across humor and sarcasm. Those who can do it, exceptional writers. I can't do it. That's why we a lot of times people add like kappa or something so it can be correctly interpreted. Those who can write something silly or sarcastic and not employ emojis are really good at what they do. Till I lose my voice. You know what I found? When I'm not like streaming for a really long time, like a month, when I start streaming again, I can only go like an hour and a half, and then I start to lose my voice. Then after like a few weeks, I can go 3 hours. Then maybe after a month, I can go 4 hours. When you get to the point as a streamer where you can go all day long, you can do 12 hours, you can do 24 hours and not lose your voice, then you know you've reached that level where kind of like like if you're a runner training for a marathon, when you can just keep going and you don't get tired, you know you're ready to do that marathon. So with the streaming, I know I'm not ready to do a streaming marathon. I'm about at the 3 hour to 4 hour point where I lose my voice. Yeah, exactly. Vocal cords of steel. It's also important to hydrate. So gotta have a big water bottle ready. That's sort of an inside joke with another stream that I'm a mod in, by the way. Okay, where was I? Interp, right? Interp gives us an optional vector of key value equals. So we could have nothing. No, it's a semicolon, right? So semi gives us none. Otherwise, it's a left brace, not bracket, followed by KVs, key values, followed by our brace, gives us some KVs. There we go. There's the grammar. So that should now compile, and let me run the tests. Okay, semi, I forgot to define that. Yep. I knew it. The real question is, this has got to be pretty late Friday night for most people. My viewership is going to probably start to drop at some point, right? Maybe that's the point at which I go to bed. When people stop watching. Then I get up in the morning, and if I feel like it, I stream again. Sounds like a plan. Run those tests. The other thing that I've noticed as being a streamer, until I get into the groove of streaming, I have trouble thinking after a few hours because I'm doing a lot of talking while I'm working. And so I'm splitting my attention 2 ways, 3 ways if I look at chat. And that could be very tiring. Cool, so this works, right? Everything works. So we're gonna move on. I want to power through some of this grammar here. So when we get up to this optional conditionals and stuff, this is all building up statements, right? And that's the meat of the syntax is statements, because formats have statements in them. I almost want to like jump up to format at this point But format needs statements. Statements need statement. Statement needs statement body. Statement body. Why do I have a separation there? Completes a statement by attaching location of the statement to the in the input to the statement semantic value. A statement may be thought of as a discrete step in composing a sequence of input data bits. There are many types of statements. Why do I have a separation here? Just for that. I think I know why. Because there are so many kinds of statements, it would be redundant to say that in all of them. That's why I did it. Still, it's so late for you. You've gone out and come back already. I see. You know, if I go long enough, the people that went to sleep in the first hour of the stream will wake up and start watching again, and they'll say, "You're still streaming? Do you not sleep?" I've actually had that happen before. If I stream like 12 hours and they come back and like, "You were streaming when I went to bed and now you're still streaming." Oh, I'm tired. Okay, statement body. We have op look ahead. We have op ID. We have op expressionless. We don't have op assign or op bound. We have interp. So if I do op assign and op bound, I'll be able to have the first kind of statement body, and then I can actually build up to a format that way. So let's look for op assign. Oh, that's easy. We have ref now, so it's either empty or arrow ref. Cool, we can do that. Interp. We'll copy and paste that, and we'll call this op assign. Tests mod op assign. Okay. You always think to yourself, go to sleep? You're making me yawn just by saying the word sleep. The no video games restriction is a personal choice? No, it's a company choice. I'm not supposed to work on games. Streaming has been really weird in terms of attention and thinking. Also, shyness plays a role in the situation. I found... Good evening. Which have you found to be the advantages of Rust over C? I can play games. I can't code games on stream. But my experience is that I'm not a very fun person to watch playing games. Other people do it much better than me, and I get too anxious when people watch me play games. Games is more of like a social thing with friends for me, or a relaxation thing, and I can't relax while I'm streaming. So, answering the question, what have I found to be the advantages of Rust over C? I had a list for that, but I don't know where I put it. Really, really briefly, let me find some Rust code. Actually, there's a good thing I can show you. Not here. Maybe a reference. No, that's not a good one either. What am I looking for? None of these are good to answer your question. I'm trying to find a good example I can leverage to explain why I think what advantage Rust has over C. What is a good example? Okay, well, let's just take this type reference for an example, okay? You can't really do a couple of these things in C, can you? So this is a type that really is just redefining some other type. It's called a new type. That you just can't do that in C. One advantage for this is now I didn't add any bits to this vector. I just kind of put a wrapper around it with a different kind of name. And we can use the outer name and not have to know what's inside if we pass the value around. I guess you could do that with a C struct though, couldn't you? So that didn't really work. Okay, then reference part. There is no string type in C, and there's also no vector type in C. The closest you can get in C to a string is a pointer to one or more characters, and you don't know how many there are. So you're forced to either have a null terminator at the end, or you have another variable, which is the length of the string. Same thing with a vector. The closest you can get it to a vector in C is a pointer to something that's one or more things, and or it's null, and then you have to check the null. Whereas in a vector, the vector tracks the memory for you and also knows how many of it is. So you can have 0, 1, or 2, or any number. Indexing into that vector does bounds checking for you. That doesn't work. None of that is done in C unless you use something like the address sanitizer that you get with Clang, right? So there's just a lot more things built into the library and the language in Rust that just don't exist in C. I feel like Rust is more C++ competitor than C. I think really it's a modern language and C is an ancient language. So you're going to have the differences between modern and ancient things that you'd expect. There are just a lot of facilities and simpler ways to represent things in Rust. In C, it would be like you'd have to add a bunch of things that collectively mean something very concise in Rust. You know what I'm saying? Strings are a pain and there's no vectors. Exactly, right? So in C++, you have standard string, right? So you're getting closer to Rust, and you have standard vector, also getting closer to Rust, but there's still no bounds checking by default in C++. Unless you like add special extra instrumentation to the language. Like if you're drink the Kool-Aid C programmer, nothing about Rust will convince you. But if you're C++, yeah, raw pointers, WTF. Rust is like, buy me a drink first. The way you do it is your character says 7-bit and the last bit indicates that the string is not over yet. Oh, that works for ASCII. Yeah, use that 8th bit, which is not really used in ASCII. And then you don't need that null byte at the end, right? Hopefully your strings are all less than 8 bytes long so that you're actually saving something. Or are you, you could still null terminate it, but then you actually use only 17 bits and the 8th bit is the first bit of the next character. And so everything is slightly shifting by 1 bit every byte. Okay, well, let me give a more accurate answer to advantages of C over Rust. So I like that in Rust, the compiler does a lot more checking at compile time than C does. So a lot of my mistakes are caught at compile time and not at runtime, which I see as a big advantage. Universal truth about programming is that the earlier you can catch a bug, the better. So if you can catch a bug before you're even compiling your code, that's much better than being able to compile the code and then sometime later you have a crash and then you figure out at runtime that you made a mistake. You lost all JS developers. You can still compile JavaScript, right? Yeah, that's maybe the number one thing that I like about Rust is that it's more strict, and so it catches all my mistakes earlier. Does Rust have a standard nowadays? It's got a standard every 3 years. So we're up to 2021 standard. So they call it an addition. And I don't know if it has a formal specification, but there's like incremental changes every few weeks. And this addition is sort of like a big bundle of like things that now won't change. And so it's like a point of stability. Like once you get to the 2021 edition, you're like making a statement that all of the things in Rust up to that point, you're going to form as the foundation for your code. I think the cat just knocked something down from the other room. Yep. And then that was one of my kids yelling at the cat. You want to be a programmer so you can get bugs with code and not without? Okay. I totally like lost what I was doing. Op assign, that's what I was doing. And the cat wants in. Okay. Knocked down. Oh, she's done that a lot before. We'll take this off of you. Here is a cat. She would like to say that she wants my attention. And why the hell am I streaming this late? Okay. Yeah. Did she actually break something? Oh, well. You don't need to clean it up. I'll just clean it up later. Apparently she broke something. Like a candle holder or a candle or something. Okay. Interp. Op assign. Okay, so we have none if it is empty, right? Yeah, empty. Otherwise, it's arrow followed by a reference. So, ref. We haven't used the arrow token yet. So a reference, that would be an identifier. So we would have some, and then what do we, I guess we just want to perpetuate the reference, right? So that would be some reference, and it's just that. That. And I don't need this. So yeah, the result is an optional reference. What is it like not like about that character? Oh, I can't call it ref. Reference. All things are just for cast to break. Are you a cat, gnarly quack? Okay. We didn't use expression or key value. We need to actually make the grammar. Let me do this before I forget. Arrow. Oh, we have a huge first time chat. Hold on. Shayna, hello, first time chatter. Traits, variadic enums, procedural macros built into the language, FP style composition iterators, as well as pattern matching, the tooling around the language, the fact that it's not limited to low or high level. Could be as abstract or low as you like. Very simple implementation of concurrency, built to extend library, lessons learned from many years of programming, language development being implemented on a freshly laid foundation, no backwards compatibility holding it back. Wow. You have certainly found a comprehensive list and written it in chat. That's a Rust explosion, if anything, yeah. You've been lurking. Okay, cool. Let's see. Do I agree with all those traits? Well, C++ has pure virtual interfaces, or pure virtual classes. That's the same as a trait, right? Variadic enum. I like the compact and cohesive variadic enum in Rust. But you can have a variadic enum in C and C++. It's just you have to enforce the rules yourself. Procedural macro is built into the language. It's a lot better than the black magic of the preprocessor, I guess. Yeah, FP style composition of iterators. What's FP style? Like, do you mean like functional programming style? Okay, then yes. Do we have some of that in C? You can sort of do that in C and C++ with function objects. Yeah, I think it's just easier to express a lot of these things in Rust, but it's not like you're missing it in C or C++. It's just harder to express. Tooling around the language, that's a good one. There are C, C++ tooling environments where it's more like comprehensive, but it's not universal like Rust, right? In fact, it's not limited to a lot lower high level. Well, that's true for C and C++. Same thing with abstractor, as low as you like. The very safe implementation of concurrency, yeah, I think that's definitely in the category of advantages. But then there's the flip side of how hard it is to make multi-threaded code in Rust. It's actually pretty hard because you have to worry about ownership, send and sync, and then the async mess. No backwards compatibility holding it back. That's not exactly true, right? There's still the repc and the FFI stuff. It doesn't really hold it back. It's more of like, it's a point of enforced stability. It can't change because otherwise it would break backwards compatibility with C. You started writing a year and a half ago. I mean, C++ is stealing a bunch of features from Rust now. Is it really stealing it from Rust, or is it stealing it from the collective group of modern languages? Because a lot of these things aren't invented in Rust. They were invented in like OCaml or Go or Zig or other languages. And then Rust is sort of borrowing from some of them too, right? Say stealing to be cheeky. I would just say that like that's just modern languages. They all borrow from each other, right? Rust stole it all from Haskell? Could be. Yeah, I'm not disagreeing with you. Okay. We're doing oppa sign, right? Is an optional reference. So there's the empty rule, which means none. And then there's the arrow. And then the ref, which gives us a sum R. I think that's all I need to type there. And then this should just work, right? So as usual, most of the time is spent writing the unit test. And then this just works, right? First try? First try. Yes, first try. I love it when things work on the first try. See, another example of why I like Rust. Once it built, I was fairly confident it would just work. It's also GNU Pure with attributes can help in preventing side effects. See, I don't know these things. It's interesting to read what you guys write about these things that I don't know. Today's new programming concepts are like 40 plus years old. How so? You mean like they're used in obscure languages and they're coming back in fashion? Because I can see that, yeah. They can make C look like assembly using macros and functions that change the stack. It was scuffed and pointless, but it kind of worked. For what? What's the context? Okay. Really just a nice bundle of lessons learned built around something never done before. Borrow checkers and alternative garbage collector. Well, the borrow checker isn't really an alternative to the garbage collector. Um, the it's not the borrow checker that does that, right? It's more of the lifetime, the lifetime algebra in the language, right? Borrow checker is making sure that you don't violate. Well, maybe it is the same thing then. So it's that whole system of the lifetimes of values, and borrow checker is making sure you don't violate any constraints within that, right? Borrow checking is garbage collection, then so is RIAI. Well, garbage collection I always think of as it's really not incompatible with the borrow checking or like RAII. It's more of just like when do you free your variables? Garbage collection says you don't free them right away. You mark them for deletion and then you wait until a garbage collector comes along and then just deletes all of them in a bulk. The theory being that you can delay, if you delay deallocation, you can wait until the system is more idle, or you can wait until like a dedicated thread is ready to do it. And then you don't spend so much time freeing memory in your main thread. That's the way I see it. It's just like a deferral of memory management until some later point. You still have to, even with garbage collection, you still have to know when something is still alive or when it's not. Or you'll have like a reference count, or you'll have like some path to it from a root, however you do it. It's not that much different from the way the borrow checker works. RAI's way of dealing with the same issue garbage collection deals with. Well, fundamentally, the problem is how long do values live, and then when do you destroy them? So do they live forever and everything leaks, or do they live for a limited time, and then do you delete them right then and there, or do you defer it to some other process like a garbage collector? What's the best diet for programming? I don't know. That seems like it has nothing to do with programming. All right. You guys are like so interesting that I'm not getting any work done. You're too interesting. Problem with RAII is when you borrow the resource you allocated. You mean like when a value escapes? When it escapes its scope? Yep. Everything has to do with everything else. That's very philosophical and meta thing to say. You have multiple files to write down thoughts and ideas about software programming. You have like 40 pages now. Okay, Red, he left you. I'm trying to follow the thread of your comments, and they're all over the place. Okay, stream of consciousness is fine. I can dig that. Okay, op assign. Hold on, are we done with this and we're moving on to the next thing? Here we are. Okay, I'm just losing track of what I'm doing. So op assign is done. The other thing I needed was op bound, right? Which is very similar. Instead of a reference, it's an expression. Instead of arrow, it's a colon. So I'm gonna just totally copy that to op bound. Reference it in tests. And op bound. Here we are. Assign becomes bound. We either have none or we have colon, and then it has to be an expression, right? So let's just pick something simpler, an integer. Then really it's going to be some expression, right? Literal integer 42. My typing is really bad the later I go. The command dot is not giving me an action to import, but I noticed that if I put a space, there, or if I type the last character expression, it lets me hit enter to do a use, and then I hit save, and then it fixes it, which is really weird. That's expression. Okay, so this is not reference. This is some. There's none and some. Probably should have done the same thing in op assign, right? Some, none, and some. So let's do that. Okay, retroactively. Okay, we don't need any of this. Then we add the grammar, and we already have colons, so this should be a lot easier. In fact, I'm just going to copy this. So it's colon and then some exper, and it's just going to be some e. Easy. I'm so confident I'm just going to run all my tests on it while I read chat. Rust just proposed a new approach, extending upon RAII in such a way that no other language I know has done before. Apart from that, yeah, pretty much everything came from other languages. Okay. The some nuns, not the none nuns. Okay. Hey, look, we passed all our tests. You know, I think the cat's messing with the broken thing outside, so I need to check on her. Sorry about that. I had to clean up broken glass. All right. Now that the broken glass has been cleaned up, yeah. Oh, you heard me sweeping up the broken glass in the other room? So the cat knocked down a candle that was in a glass candle holder. I did it fast because I just it was in a small area, so I just swept it up really quick. Yeah, I said that she'd do that. Yeah, well, it's just the price I have to pay. $88 tests pass. Okay, so then I have op, assign, and op bound ready to do statements. I think so. So we can make a statement body now, given all of this junk. Gonna set all memory pages to read only, and I'm going to enable the writable bit on the pages I need to write to when I enter functions that I write to a specific page. Memory is statically allocated. Oh, what has she got now? Oh, that's your collar. She's playing with her collar. That sounds really familiar. Isn't that how you would do a copy on write memory management? You would set all the pages, not to read only, but you'd set them all to cause a trap. And then the first time you write to it, you would actually, well, no, it's kind of backwards. Interesting, though. All right, let me get back to what I was doing. She's really being a bad cat now. Like running up to me and then messing around with stuff and then running away. Okay, I have too many things open. We're just going to do a global close everything. Okay, and then within parser, source, tests. Let's copy something simple. Call it statement body. And then in tests mod statement body. Okay, and then let's open format.y. Here we are again. If the locations are allowed for write are well defined and there's limited amount of elements in a page, you can record all runs of a program. You compare runs and guess why something went wrong probably and fix it automatically. Okay. Okay, see you, gnarly quack. 40 are not viewing. I think I'm experiencing the phenomenon that as people are leaving, new people come in, and then we're slowly shifting through different viewers. So, which means I'll never go to sleep because I'll never run out of viewers. Okay, so what are we going to construct when we match a statement body? We're going to construct a statement part. So I'm going to have different kinds of statements, right? So we're going to need an enum. Yes, bad cat, I see you there. I'm going to put our collar back on. Did I put that on right? Yeah, okay. Before I forget, put her collar back on. All right. Make a new module called statement. RS. Go to the top level. Make a mod statement. Okay, statement. Let's copy from like expression's too big. Copy from this. Need this much of it, right? Really only need this much of it. Statement. Actually, it's going to be an enum. The only kind of statement we're going to start with is part. And its format, which is a string. And then we need, well, I call it sub format, but I think format's fine. So there's an optional, it says part, but what it really is the name of it. So we'll make that name. It's an optional string. Thoughts on UFOs? Don't have any thoughts on UFOs right now because I'm working on this program. Unless you mean undefined fixed objects. And then I would say that all fixed objects are defined. Therefore, there is no such thing as a UFO. Let's see. L value. That's for opposite, right? Yeah. I guess I'll just name it the same. And that's a reference, right? That one's a reference. Bound was an expression. We're going to put those both in. So this is an optional reference. Bound. Optional expression. Actually, the bound has to be a specific type of expression, now that I think about it. Where do I check that bound? I probably use coercion. Let's see if I do that in the C implementation. Yeah, so what I did is I did the coercive evaluate expression. The one where it says it coerces it to the given type. So it's going to coerce it to to an integer value, and it's going to use that as the bound in bits. And if we can't coerce it, then we get an error. I gotta let the dog out. Hold on. Who let the dog out? All right, go back. So we have format, we have the name, L value. I don't have the arguments or the interpretation or the look ahead. Look ahead was a flag, I think. So look ahead. And then just need args and bound, right? No, I have bound. So I just need the arguments. So this was optional expression list. Thing with optional expression list is it could be none, right? Or it could be yeah, it's an option vector. That's sort of silly, isn't it? Why would I ever have to have both some empty vector and none? They mean the same thing, right? So what if I change this to be just vector? And then this becomes just empty vector. And then I can just do that, right? Yeah, why do I need to distinguish? Why do I even need this? Why don't I just put expression list? Because expression list is allowed to be empty. Oh, I know why. Because sometimes you know there has to be an expression list. It's optional because we look for the parentheses to delimit it. That's why. So, okay, we keep that. It's just that it's not an option anymore. So that means I'll always have a vector of expressions for the arguments in a statement. Like that. Let's put it in order, because why not, right? Arguments bound, format, look ahead, L value, name. What else? It's 6 things. 1, 2, 3, 4, 5, 6, 7. Interp is what we're missing. There it is. Okay, key value done. So that's probably the most complicated node in our abstract syntax tree that we're going to have. Okay, so then I was going to write the statement body test first, right? So then we'll just have one for a part. And we have no other test cases to start with. This is a statement body parser. Hold on a sec. See, did you know that I am not only a streamer, I am also the doorman for a dog? Whenever the dog needs to go out, I must open the door. Whenever the dog wants to come back in, I must open the door. It is true. Okay, so the result is going to be a statement. Also, we need to import that. So we don't need expression. We just need the parser. And I have to fill this in. So this is going to be state. Hold on. Let's actually write the statement first. Part. Okay, and then I wish it would format this for me. It's not going to, so I'll have to do it. Humans are slaves to their pets. Again, the cat that I had a couple of years ago who finally passed away from old age, he was a saint because he didn't ask a whole lot from me. He just, once in a while, he wanted attention. He wanted me to feed him and clean his litter box, and that was all he needed. This new cat will break things if I don't pay her enough attention. And actually, our dog is pretty nice. I just have to let her in and out and feed her and give her water. That's not too much to ask, right? Okay, so you know what I'd like to do is just have the most complicated part that we can. So maybe well, actually, the subparts are tested separately, right? So I don't really need, I can go minimal here. I can have the arguments just be a vector, empty. What are the optional things? Bound, interp, L value, and name, right? Bound, interp, L value, and name. Actually, you know what? That's probably not a good idea because this won't test that. This won't actually test the order of things. So I shouldn't do it none there. I should have something there. Gosh darn it. But I can have something minimal. So the arguments can just be like expression, literal integer, 42. Interp is some key values, right? Which is a vector of a key value. Again, the import thing doesn't always work. If I wait long enough, it'll do the use for me, and then I can do a fill fields, and that works. Okay, look ahead. This will just, we'll actually put one in there to make sure that we see it. And then, yeah, L value will be some And this has to be a reference, right? So reference is a vector, right? Of reference parts. And a reference part has pieces in it. The ID and the indices. And I can have just the simplest one, which would be an empty vector for indices, and the ID is just a string, right? Foo bar. Foo. Getting there. So, what's wrong with my expression? It's not imported. Okay. Format. That's definitely a string, right? So how about bar? And let's have some bound here. That's an expression again, so let's put another literal in there. 67. Why not? Okay, so these are all expressions, right? 12, 34. And let's give it a name. So this was some Baz. Okay. Whew. Okay, so the input tokens for this. The format comes first, right? Bar, which is, so it's going to be a token identifier. Okay, and then after that, the for the argument list, it's a token LParen, RParen combination, right? And the args is token literal, token integer, 42. So there's the parentheses to the part. Ah. There we go. What does test case come from? It's actually a crate called test case. So it's at version 3.2. We actually use it. Why do I have a to-do remove if not used? We use it. There we go. Yeah, it's a pretty cool crate. So I can just give you a preview if I just go to test case. So crates, like it says, procedural macro attribute that generates parameterized test cases. So with one function, you can have different input-output combinations. So it's just a way to like shorten your test cases. So this is like making 3 different tests with one function. It's pretty sweet. So I'm using it here in a degenerative case where I only have one test case. But if I had like the more tests I have, I just have to say what's different about it. What's the input and what's the output, and then a common test just accepts any kind of input and expected output and compares them. Yeah, it is pretty cool. How are you doing, dude, man? I'm wondering if that should just be statement parser, and we make statement body just a tier of it. I think that's what I'm going to do. This is going to, whoops. This is just going to be statement parser. And that means I'm going to rename statement body to statement. Yes. File, save, all. Okay. Yeah, sorry, I don't have a GitHub. Again, RegAlias3, you probably missed it, but I have a job right now, and there are 3 conditions of me streaming while having this job. Number 1, can't talk about my job. Number 2, can't do game dev. And number 3, I can't do open source. So that means, although I had a GitHub, I haven't updated it since I got the job, and so I didn't bother having the bot have a GitHub command because I can't actually publish this on open source. Yep. I should make that like there should be a command. You know what I should do with my bot? I should have a command that like says what my rules are and then alias GitHub to that, game dev and job. So if anyone ever asks about GitHub, game dev, or job, it just said the bot will say Raimu cannot do these 3 things with the job he has. Job rules, exactly. I should have a job rules. Yeah, when I'm not so focused on getting this test to work, I think I'll do that. Yeah, I know. Sorry. Dan's game is true. Monoided. Okay, so I was making the statement, right? The statement, the format is bar. It has a 42 for a parameter. And then it's the name. So that would be another identifier called foo. No, baz. Bar baz. And now I'm starting to not remember. Oh, we have to put the look ahead symbol. Right. So that's a plus after the format name before the arguments. Token plus. That's like the marker that we put into the syntax to turn the look ahead flag on. Then the ID, which is baz, and then the argument. Oh, okay, the argument list comes after baz. So yeah, this name, no, sorry, this identifier goes before there. So it's bar plus baz parentheses 42 bar plus baz parentheses 42, and then the assign, that was like an arrow, right? Yeah, an arrow and then a reference. And then the reference would just be another identifier. Boo. It's that. And then the bound was colon. So this is basically exercising all the optional things that we can have in a format. It's been a while since I've shown an example of the actual format, so let's do that. So here's describing the GIF file format using my format language. So each of these is like that's a part, that's a part, that's a part. So parts can be as simple as just a format name and a semicolon at the end, or they can be as complex as something like this, which has this is a special ignore statement. That's the format, unsigned integer. The plus means it's a look ahead. The arrow next means to take the value and store it in the local variable next. Colon 8 means it's bounded by 8 bits, and then a semicolon. Actually, it could be even more complicated if I replaced that with an interpretation of some kind. And if I gave it a name, which would be like LA or something. So that's one of the most complicated part statements we could have. But hopefully this kind of makes sense. So like a GIF file starts with a header and logical screen, and then we have 0 or more data blocks and a trailer. And it kind of matches what the GIF file format specification says right here. There's a header, logical screen, 0 or more data, and a trailer. And the language is sort of a combination of structure definition and logic. So we can have loops and we can have conditionals, but overall it's just kind of describing what constitutes a GIF file in order. And you can nest things. So header is fully described here. And we have certain built-ins like UIs for unsigned integer and S's for string, but most things are user-defined. So we're talking about a statement, which is one. That's a statement. That's a statement. That's a different kind of statement. But one kind of statement is a part, and that's what this is. Something that begins with an identifier is a part. So colon, and then the last thing was the bound, right? So that was this integer 64, 67. Will you be doing admin code this year? I hope so. Do I have an AOC command? No, I must have deleted it. Yeah, if you guys don't know what advent of code is, I'll probably be doing it this year. It is something that happens in December. Advent of code. So it is an advent calendar of small programming puzzles for a variety of skill sets that can be solved in any programming language you like. So last few years I've been doing it in Rust. I didn't actually finish advent of code last year because I think it was because it was doing some house renovation and it was just too chaotic and stressful. And so I didn't actually do it last year. But I'll probably be doing it this year, yeah. Watch my past ones? Nice. Would it be too boring if I did it in Rust again? Should I pick another language this time? The most impressive advent of code solutions I've seen were done in SQL or Squeal or SQL, however you want to pronounce it. Do it in Mojo. It was Anthony Writes Code, who also streams on Twitch. He would do solutions in SQL. And I never thought that you could make general programming solutions in SQL. I thought it was just a database language. But apparently you can. Some of his solutions were really wild because of the limitations of SQL, but he did it. Okay, granted I have a grammar for this. This should work, right? Oh, man. Talk about rusty. My throat's getting rusty. Postgres. Stored procedures. I think, is that what he did? Probably. Probably used stored procedures for oops, sorry. For all the general programming. Say pub statement. Gives us a statement, right? And the statement part would be, I can't do this without copying, so I'm just going to give up right now and copy. It's this long thing. From the old grammar to the new. Let's just take the old grammar and we'll adapt it to the new. So identifier subformat becomes subformat, or actually we're just going to call it format, colon ID. Okay, and then op look ahead. We want to call look ahead. So yeah, this is how we put what was in braces before to the left, and we use the angle brackets instead. L value bound interp okay, and then we form a statement part, and I can actually just cheat and copy from our unit test, right? Or I can copy from here. That works too. Args we have. Actually, all of these we have. Can I do multi-cursor? like that, right? And then if I'm going to do that, that part is actually name, right? Name. Look ahead, L value. Args. That all looks good to me. Value bound, interp. Oh, this has to be interp. Then if I do it that way, can't I just put all these on one line? There's no rule that says they have to be on separate lines. It is getting quite close to the edge though. Hey, but it fits. Look at that. Actually, what I really want to know is, can I extend that to the next line? Can I do that? Because that would be even better, right? Let's see. Does this build? It failed because statement is undeclared. We got to declare it. Hit here, right? Interp instead of op interp. Did I make a mistake? No, there's no op interp. It's just interp, right? The original grammar, there's always an interp there, but an interp can be empty. Yeah, it's one of those weird ones where the rule didn't have the word op in it. Maybe it should have. I think it's because it wasn't empty. No interpretation was just you end in a semicolon. If you ended with braces, then you have an interpretation. So you always had to have something, and a semicolon is a explicit thing saying that there's no interpretation. I know that's a weak argument, but that's what I'm gonna go with. Oh, it already built. What am I doing? So cargo test, right? Wait, oh right, I changed optional expression list a little bit, so I need to fix the test for that. So this is no longer an optional vector, it's just a vector. Because optional vector is sort of redundant. If there's no difference between a none and the sum empty, then might as well just make it a vector, right? So then we remove the sum versus none, and then none becomes like just an empty vector. Right. Okay, now fix the statement. I thought that had it marked an error there. How come it's not doing it now? Okay, it built, but we have a okay, the one we just wrote failed. Unrecognized end of file. Expected all of these things. The thing is that the location 01 is a total hack. Because every symbol ends in 01, right? Actually, you know what would make this more useful is if I did an input into iter.enumerate map n.token. I can't remember which one's first. You can see. Yeah, n, and then use that n here. So that would be so rather than an into, what if we just use a location directly? And then I can fill in that line number would always be like 0, but then the column number we can use is we can put the n there, and then we can have this one be end is n plus 1. What's wrong there? Private? Private? I never made them public. So now I can run the test and actually see like which token it didn't like. Actually, unrecognized end of file means it probably got to the end. So it should probably be the count of the number of tokens I have. Yep, location 10. Probably 10 tokens up there, right? 1, 2. Oh, did I miss the interpret? I did. I missed that part. Oh. So, OG, you were sort of on the right track there. It's not that I should have called it op, it's that I forgot to even put it in my input. That's what you were getting at, right? That's totally what you were getting at. R brace. Yeah, I have to put these integers in there, right? So it's something colon something if I have an interp. 12 and 34. Yeah, this is a very complicated test. So we can say that that's the interp. This is the bound. This is the L value. Assign. These are the arguments. This stands for the look ahead. And this is the name, and then this is the format. That makes it a little bit easier for me to read. Yeah, well, in a way you did find an outlier, right? I was actually missing that, and the unexpected EOF was the correct error. Hey, look, it parsed it. It only took me like a gazillion tries, so that's one kind of statement. And then let's do the next one. It's almost midnight. When do I stop? No, I'm not going to do a 24-hour stream. But I might stream tomorrow. It just won't start as early as normal. Right, I have the ignore specification, and I've been toying around with the idea of merging these two because they're almost identical. The only difference is an ignore specification doesn't have a name. So between the look ahead and the expression list, there's nothing. Whereas with a named part, you have an optional identifier there. So if I put minus, optional minus in front of that, then if it's not ambiguous, then I can merge these two together, right? There's also not an interp for a ignore. There's always just a semicolon at the end. That's the other thing. Because it didn't make sense to me that if you're ignoring all the bits, why would you want to interpret them? But you still need a bound. Actually, there's no real reason to have an op assign either. Oh, I added that, right? I added that because actually I'm using that here. That's an ignore specification, and I needed the assign to a local. But there's a reason for that, and that was something didn't work, right? Yeah, I think it's that I couldn't name this next. Like I wanted to just call it next. And I can't name ignores. I think I was thinking about this between streams actually, that if we're doing a look ahead, that means that we're going to dump this value at the end. Then we don't have to call it an ignore. We can just say it's a look ahead, and then this name is automatically a local, and therefore I don't need to do that. That actually look better to me. So the next 8 bits is an unsigned integer, and it's a look ahead, meaning that we're going to store the value in next, but it's a local variable because it's a look. We're rewinding back anywhere, and we're going to parse the actual next 8 bits as either a data or a trailer. So this is only going to be a temporary thing, right? I don't want to do 2 things at once. I don't want to port it to Rust and at the same time change the syntax of this. So I think I'm going to do a faithful port and then change it later. Okay. It is largely the same, so I think what I can do is just copy paste the test case. So we have now, instead of a part, we have an ignore. And what's different about an ignore is it has no name. It has no interpretation. And the name is ignore. So let's define that here. Ignore has no name, has no interpretation. Otherwise, it has everything else. It has a bound, it has arguments, it has a format, a look ahead, and an L value. Okay, so then here, how it's identified as an ignore is it starts with a minus token. And then there is no name. There is no interp. Okay, and then I just need to fill in the syntax for it. So that kind of looks like a part, only it starts with a minus. There is no name. There is no interp. Instead, it has to end in a semicolon, right? So semi. So that's an ignore with no interp and no name. Okay. Actually, shouldn't that be indented like that? That I'm not. What's the right formatting for this? If I have to go over one line, I kind of feel like that should be indented, but then should that be indented again, or would it be better to do like this? Actually, I think that looks better. So it would look like that then. Then I can kind of see where one thing ends and the next thing begins by looking at that thing. I can pick whatever formatting style I want, so that's what I'm gonna pick. So we're done, right? Run the tests. Should be 90 tests passed because I'm that good, right? Nope. Failed. Unrecognized EOF. Well, did I put a semicolon in there? Did I forget? Where is the, here it is. Oh, yeah, that's why. I didn't have a semicolon at the end. The delimiter, right? That test target and cargo is a nice touch. You mean the lib? Or the fact that I can just run cargo test? Couple things going on with that, right? This looks for everything marked test, and test case generates things marked with test. The --lib, if I didn't do that, it actually runs the doc test too. I didn't like that because it would always run it after the library tests, and so it would always say 0, and I'd have to always scroll up to see the real test count. I found that really annoying, so that just, now the bottom line is the last line. Could just run tests from the build system. Yeah, that's one advantage of Rust. We were talking about advantages of Rust over C, for example. And this is one of them, that you can test and you can also run straight from the cargo command. And there's other, you can actually, it's open-ended, so you can actually install plugins to cargo to do other things. So like when I was building the firmware for this keyboard, for example, I installed binutils, cargo binutils, and so you can do like cargo elf to bin, and it would not only build the firmware, it would convert it from elf format to bin format for me. Super convenient. And there are lots of plugins to Cargo that other people use that are super sweet. Like there's ones to do like measuring memory footprints or code complexity. Yeah, it's super useful. Cargo update downloads the latest versions of your dependencies if they've changed. All sorts of cool things. I'm jibber jabbering too much. Okay. 90 tests passing. Conditional logic, if statements. Okay. It's almost midnight. How much more statements do I have? This is a for loop, while loop, bounded region, local attribute, assignment, accumulation, increment, decrement, return statements, break statements. There's a lot I can do tomorrow. Maybe this is a good stopping point and I get some rest. So let me bookmark this one. So I guess next stream we'll start with conditional statements. We have an example of that right here. This is a conditional statement. Yep. Yeah, I'm tired. Nightshade dude's tired. We're all tired, right? Wow, people are still streaming at this late hour. How about we raid Evan? Because I haven't raided him in forever. Those were the conditional statements in the 70s. Yeah, with the parentheses. I could probably do away with the parentheses, right? Because the if and the left brace are delimitation enough. I could probably get rid of these. Anyway, we're going to look at that tomorrow. Probably what I'll do is after I pour all this to rest, then we'll talk about these grammatical improvements we can make. Nowadays, conditional statements don't need to be parenthesized. I still need a brace because we need to know when an expression ends and a statement begins. I could check by removing the brace and seeing if it's what do you call it? If it's ambiguous or not. If I can remove the brace and it's non-ambiguous, then well, we still need a right brace to separate the last statement of the if from like an else or something, right? Throw in some gibberish English looking text to large language model and ask if there's a condition in there. Good one. Okay, I'm going to start this raid. I haven't hit the button yet. Here we go. I'm hitting the button. We're going to raid Evan. He's been working on an MMO for the longest time. Have no idea what he's working on tonight, but I got to go to sleep. And you guys need to watch something else. Because we just can't leave you hanging. That would be rude. I'll see you later. Bye. Is it still hunting good engine? I don't know what we're talking about, but bye, 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 bye.